off and on like.
Hello, hello. Hello. Welcome everybody to McMaster today for our BAT meeting, Ontario BAT Network. We're happy to have everybody that's been able to join us in person today. And as I mentioned earlier, for those that are in person, we are also live streaming. So just a heads up, if you're anywhere near that camera, it might pick up voice. So just something to know. We're recording all of the presentations today. Just another heads up. Main part of this was welcome you all today, and Christy's going to do our land acknowledgement, and then we'll do some housekeeping, and we'll get started.
Thanks. So just to start the day off here, the organizing committee of the OBN would like to acknowledge that while we're here, gathering here at McMaster University in Hamilton for the Ontario BAT Network's annual meeting, we are also gathering on lands falling within the traditional territory of many First Nations people, including the Anishinaabe, Haudenosaunee, and Attawandaron, or neutral peoples. We're really thankful for the stewardship of the land, this land that has been undertaken over thousands of years. And we remember the treaty between the Crown and the Mississaugas of the Credit First Nation called the Between the Lakes Purchase, which was signed in 1792. This stewardship of the land and this treaty have allowed us to gather in this place and also allowed us to undertake much of the work that we will hear about today. And we acknowledge each of these with respect. We do invite everyone here today and watching online to consider how this stewardship of the land and the example that it sets informs our relationship with bats now and how it will inform it in the future.
Super. Thank you, Christy. All right. So housekeeping. As I've mentioned 4 times already, and I'll probably mention a bunch more times, we're live streaming today. We're pretty excited to be able to do that because it's been a heck of a challenge. Yeah, we're ecologists mostly. We're not tech people, so it's fun. Presenters are going to be running by the schedule, which many of you probably have, or you can get a copy of it at the front desk. We have a bunch of them printed out. So those are available for people if you're looking for the schedule. We also have the schedule that has been posted multiple times online for those of us visiting online so that they can follow along with the presentations they're interested in. For the speakers, we have pretty limited time today, so we have moderators for each of the talks. Speakers will be notified at 2 minutes and 1 minute so that they know when their presentation should be ending. And I believe we have about 5 minutes set aside for questions at the end of each of these. We will try and follow along with any questions that may come via YouTube, but I can't promise that those questions will get answered if you do post them. But we'd love to hear them, and we'll try and get back to you after the meeting once we've seen those. Aside from that, I don't think we have much else in the way of housekeeping. We have 2 breaks today, 10:35 to 10:50 and 2:40 to 2:55. And our lunch will be about an hour and a half. And the intent of that is to allow people to walk in this wonderful weather today to get food. We also have mapping available if people are looking for ideas for where to get food. Otherwise, if you don't feel like leaving campus, we have some muffins and coffee and snacks in the room upstairs where you can get an impromptu lunch. Hopefully that won't come to that. Hopefully it won't come to that. Beyond that, I don't think that there's much. I think Nicole has explained to everybody where the washrooms and everything else is. Emergency exits in case of a fire, Paul. We're just leaving the exit here to my right, and I don't know where we're meeting.
Oh, if you emergency exits, we can gather outside under the awning.
Okay. So in the case of an emergency, we're leaving via the exit to my right, and we're meeting under the awning. Or in the back of the building. Just follow Paul because he knows where we're going. Speaking of Paul, Paul is our first presenter, so I'll call Paul up. And I don't have a whole lot to say about Paul except for we've never met before this opportunity. Paul has been excellent in helping us get this all together, and McMaster has been amazing in helping us prepare everything that we've done today. So thank you, Paul. And McMaster, Paul is our host today. One more thing before Paul starts talking. I expect that you've all spoken to Nicole on the entrance, and there are opportunities to view Paul's lab and the captive bat colony here at McMaster. It is a pretty cool experience. We got the opportunity to see it firsthand before all of this started, and Paul is a super interesting fella, and the stuff that's happening in his lab, it's pretty cool. So his students are laughing right now.
Thank you. Can you hear me? It's too. There we go. Is that better? Go ahead. Can you hear me? Yep. Wonderful. Maybe I'll turn it down some more. Yeah.
Stay away from this.
Stay away from that. Yeah, I'll stay away from that. So I wanted to say, first of all, welcome to McMaster and to Hamilton, and thank you for coming today. I just wanted to quickly acknowledge a very important person who's going to make the live streaming happen, Lucas Klein. Lucas has volunteered to come help today. I also want to acknowledge some members of my lab who are going to be helping facilitate bat tours of the colony. So if you could just, Lucas is right up front. He can't stand up because he's busy, but if you could stand up, I'll Kazuma Hase is a postdoc in my lab, Alexa Clark, and Shane Schwell, and I don't know, Renata Smolsey. Renata here? She's not here yet. I also want to acknowledge the bat colony would not exist without daily care and maintenance and love, and our animal technician has joined us today. Don Graham is right in the middle here. Thank you, Don.
Clicker so you can make it work, yeah.
I'll move away. Lucas, am I okay here?
You good?
Okay. So I'll start off. So I'm going to tell you a little bit, because we have this captive bat colony, and we have been working with big brown bats, the white rat of the bat world, as I like to call it. My students, what I'm going to talk to you today is work done by my students in the lab, and it's been a lot of fun. I'm traditionally an animal behaviorist or a neurobiologist, and because we have access to pregnant female bats and they give birth in the lab when we rear their young and can do studies on the young, and we have this very unique opportunity situation. So I want to tell you a little bit about some work that we've done. And my apologies to my laboratory and some close colleagues who may have seen this presentation, albeit a few months ago in Texas. First I want to acknowledge the folks who actually did contribute the work, including a collaborator. Carl Lyons is a graduate student. Heather Mayberry is a former grad student who did her master's with me and did work on vocal development in young pups. And she then went on to do a PhD with John Ratcliffe after working with Craig Willis as a bat care technician for some time. And Doreen Mokel is a former postdoc in the lab who did the work on hearing that I'm going to talk to you about. I also want to acknowledge the lab photographers. Brock Fenton and Sherry Fenton are always very generous to come to my lab, take pictures of me and my students, and of course mostly take pictures of the bats. And almost all the pictures you're going to see today are thanks to Brock and Sherry Fenton, such as these pictures here. So for example, we've been able to work with bats that have newly given birth. We've got pregnant bats. I'm not sure if we have an actual pregnant bat in here, but here's newly given birth, all the young pups. And you can see some of these photos, the pups have their toenails painted. There's a good example. My students, they get to do 4 years of a bachelor degree, and then they get to learn how to give a manicure to a bat, a pedicure, and paint. We keep track of which pups go with which mums until they're old enough to actually put a tag on them. So, here's another example of painting toenails. It's a lot of fun. We're very fortunate, so I want to say thank you to McMaster, because we have Canada's first and only captive research colony of insectivorous bats. And hopefully some of you will get to see the colony. Here's what a pregnant bat looks like. So later on you're going to hear a presentation by my grad student, Alexa Clark. She's giving a poster on the calls emitted by pregnant bats before and after they give birth, actually. And you can see these two giant lumps on her back. Those are her buns in the oven. And this is a couple of shots of the same female. You can see we've painted the toenails of this pup. So the young are born, the females turn upside down for them, right side up for us, give birth into their tail membrane pouch. And the first thing the pups have to do is they have to crawl up and find their mother's teat to get milk. That's a huge moment in their life. And then when you find a bat that's got pups, quite often you see it's like a vampire with a cloak around the victim. She has her two pups, one on each teat, under her wing membranes, and she'll be crawling around with those pups attached to the teat. And in the colony, the bats tend to live under towels. Sometimes they're under these wooden things. There's actually a little bat right there. They have the access to water and food trays. They have a little outdoor opening. They can crawl to a little bit of a flying area, so they have some outdoor space. It gets cold in the winter. It gets warm in the summer. And we've had in-house breeding, and we have some plants and stuff that we move around randomly just to keep their echolocation systems engaged. And then there's a little picture of the outdoor area. We took down this jungle gym recently, but when our first colony was first built, there was a little dirt trail here, and people parked. Now this is the front entrance to the university. You all came in this way, So we had to put a fence up and planted trees just to keep out any unwanted customers. And I want to thank Lucas Grevel for this video. So in the colony, if we're filming from the outside area looking in, you can see there's room for the bats to fly and move around. And obviously these guys were a little bit disturbed, but when they were being filmed. So just going to tell you quickly to tell you about some development in general, morphological, anatomical development, how the vocalizations change during development, and talk a little bit about how the hearing changes during development. And there's a face that not just a mom could love. I'm sure most people in this audience could love a picture of a bat pup. So this is what a one-day-old bat pup looks like. It's just attached with its milk teeth, and actually you can see the milk teeth very nicely in that photo, attached, and you can see it's got giant forearms. It comes out of the mum, you know, it's all wing. And you can also see it's got these really, really sharp claws that it comes out of the birth canal with. So, you know, if you're a bat mom, you have to deal with a puncture wound, maybe. And it kind of reminds me of that 1970s movie, It's Alive. For those of us who are old enough to remember that It's Alive, you see the nice clawed hand coming out of the crib here. There's only one thing wrong with the Davis's baby. It's alive. This is a picture of me in 20 years from now. And you can see, so the bats are born naked. Their eyes are closed, their ears are closed. But one of the cool things working with Brock, when he's really, and Sherry, they're particular about lighting, is when the lighting's right, look at this face. Look at the hairs all over the face of the bat, the sensory hairs. We have no idea what they're doing. And there's young facial glands are developing, like here, and there's one here. So you know, there's lots of sort of undiscovered questions still. So, you know, what could they be? Could these be used to find the mother's teat? Are they right away active for doing this? Because their eyes are closed. So this is a 2-day-old pup. Here's another picture of a different 2-day-old pup. You can see very nicely the milk teeth. You can also see that it's still, there's very little, very sparse hairs have come in. This pup's eyes have started to open, but you can see the ear is still closed. And in fact, the tragus of the bat, which is this part of you and I, it's folded right back in and it's covering the external auditory canal. Now, these pups are producing vocalizations. Anyone who's worked with bats knows they produce I calls, isolation calls, and that attracts the mother's attention. Help, I'm cold. Help, I need food. Help, I've wandered away. Come retrieve me. But the hearing was an aspect of, you know, sort of what can they hear at different ages. Here's a 3-day-old pup, which really nicely shows how the bats are all wings, like Popeye. And again, you can see very nice sharp front claw. They come out right away. They're able to climb on the mum. And you can see they're starting to see a little difference in coloration between the dorsum and the ventrum. And they're starting to see some hairs coming in. And the melanin is starting to come in. But you can see also this pup, its tragus now is starting to fold out of the ear. But the ear canal is still sealed by a skin. A 6-day-old pup, now it's starting to grow into itself. You know, the forearms they're still changing, but the pup's getting bigger. Here you can see the tragus has popped out. This pup still has its ears closed, but the fur is nice and sparse. It's no longer sparse, it's coming in dense. It's very fine. Here's an 8-day-old pup. Now it's starting to get more coarse hairs developing. Its face is starting to look much more like an adult bat. It's not quite as pointy. And you can actually see nice features of the face popping in, including the glands around the snout. The eyes are open, and in this particular pup, the ears now are open. You can see the tragus right there. And the ears are starting to be erect more often. Here's a 9-day-old bat. Now you can still see very clearly it has milk teeth. The permanent teeth are starting to erupt, but the milk teeth are still there. And just as a quick quiz, can you guess the sex of this bat? I'll give you a hint. It's right here. Here's a 6, so I'm jumping now from day 9 to day 16. There's lots of things we can talk to you about. But now, even by 16 days old, this pup is looking relatively adult-like, although it's still a good 10 to 14 days away from its first flight and being able to even think about catching insects with echolocation. Very, very sharp, bright white teeth, so it hasn't really been used much yet. So even though it looks adult-like, it has still quite a ways of trajectory to development to go. Just some data. I don't want to spend too much time on data to show you. These are wild-caught values here for adults, and here is a pup trajectory for the growth of the forearm and for the change in mass. The pups can get a little larger than adult bats in captivity. They have unlimited access to food, of course, once they are weaned from their mothers. The auditory canals. The ears, you'd be surprised, this is when the first ear opens. There's no difference between males and females. There's the postnatal day. But you can see there's a bit of variation. Ears are not really, the first ear is not even opening until day 5, 6, 7 on average. And then the second ear opens a little later. And it's not like it's a left and right thing. It's just that the ears don't open symmetrically. They tend to, and look, in some cases, the second ear doesn't open until 11 days of age. So we're thinking that they're probably not doing a lot of auditory discrimination tasks for the first 5, 6, 7 days of their life. Another thing that pups tend to do when they're hanging, when they're growing, is they'll hang off the substrate and they'll practice flight. They'll practice flight and raise themselves up and hang on with their claws. This helps to build the motor coordination, the sensory aspects. They coordinate breathing with flight. So here's an example of a pup just doing that right in the lab. Some of the vocalizations emitted by the bats as they go from very young stages where they're emitting almost all these type 1 vocalizations to, there's different types, and this is just meant to be a slice of a few types of vocalizations that isolated pups emit when there's no other individual present, but eventually they start emitting solely these type 3 vocalizations, which are the biosonar. Here's some interesting social-like vocalizations, and this is sort of a transition maybe between these long-duration isolation calls, which are used to attract the mother's attention, lots of harmonics, to these short-duration, this is all on the same scale, so these are only 3 to 4 or 5 milliseconds long. And just we can quantify how the harmonics change, they decrease over time, and how the interpulse interval changes, and I won't bore you too much with those kinds of data, but one of the coolest things is that pups, this is a 32-day-old pup and its mother, and we found evidence from this even before, well before day 32, is they start to emit these groups, these pulses of calls. So this is frequency and time. This is the amplitude, so each one of the calls here is here. And then this is the interval between calls shown here. So we have short interval, longer intervals, short intervals, and they start producing these groups of calls with very short intervals. We call them sonar strobe groups. And the moms, of course, are doing it. And we think that this is with the first evidence that pups are now starting to insanify their environment and starting to perceive their environment, and they investigate or interpolate their environment with a series of short calls, all at the same repetition rate. So they expect the echoes to all come back at the same rate, and they can just focus on what the echo is doing rather than the delay of the echo, which, the delay would be related to target range. Just quickly, if there's still time, do I have time for? Okay, auditory development. So we can study, we study hearing in the lab a number of ways. But one of the more recent ways we've been doing it is with recording auditory brainstem response, or ABRs. And we use these very fine needle electrodes that we can just insert under the skin of the bat. So we have 2 electrodes, one for each auditory bulla, which is the bulla are located on the surface of the skull eventually. And as you can imagine in bats, echolocating bats, the auditory bulla are quite large, and the areas of the brain devoted to hearing are quite large. So these are just subcutaneous electrodes. The bats are wrapped in very scientific equipment. We use pantyhose that former lab participants can donate to the lab, and they're just nice and cozy. The young pups don't even need to be anesthetized, but as they get older, we do have to give them a little tranquilizer so they don't move around. And then we can play sounds from the speaker here at a distance, and we play sounds and we can record the evoked response, and we do this over and over and over and over again, and the evoked response tends to average and the noise tends to cancel each other out. So it's an averaging system, so you need to have the subjects listen to the same stimulus for quite a few repetitions, like 250 times. This is a nice, because compared to other techniques that we've used in the lab, it's very minimally invasive, hence it can be repeated in the same animal, so you can study things like development. How does the hearing change as the animal develops? And it yields information on the gross functioning of the peripheral and central auditory system, but we don't get any information on what single neurons are doing. For that, we have other techniques. So this is a picture of a 10-day-old bat already starting to be recorded with this technique. And currently in the lab, my graduate student Shane Swelt, along with my postdoc Kazuma Hase, are using ABRs and single unit recording to studying hearing in bats. So here's an example of how the threshold of hearing of a bat changes from day 10 up to 1 month, 2 months, 3 months, and even 1 year later. And this dotted line shows a behavioral tuning curve, so animals that are trained to respond to sound, so you can measure their hearing thresholds by their behavior. These are adults. You can see that the pups, we don't even start recording to day 10 because their ears don't even open until day 7 or 8. Both ears may not even open until day 11. And each one of these is a factor of 20 dB. For those of you who don't know dB, that's okay. This is a factor of 10, 100, 1,000, 10,000. So you can see thresholds change by a factor of 1,000 to 10,000 over a relatively short period of time, and their bandwidth. We hear in this range here, 20 hertz to 20 kilohertz. If you're really young and haven't been to too many rock concerts, you can hear up to here. Look at the hearing range of the pup. It expands by expands by a factor of 5 over the course of the first 30 days of life. So we've done other aspects to study hearing, but I just wanted to highlight just hearing thresholds. Hearing thresholds are just, that's only one factor. We haven't studied things like myelination, circuit formation, and circuits can take a while to develop. Maybe auditory circuits for processing echoes continue to develop 2, 3, 4 months of life. So what are we studying in the lab now? Well, one of the things we studied recently, and this is my student Renata Samolsi, who I think is here now. Renata? There she is. She'll be part of the tours as well. So I was introducing everybody on the tours. How does the ear pinna change during development? This is a project Renata did as an undergraduate during COVID with a cell phone. How does a pup's vocal beam change with development? We can measure how the sonar system of the pups changes as they age. And what age do pups begin to perceive targets with echolocation? So this is Renata's work just showing you the development. She measured how the surface area of the ear changes, how the tragus length changes, and then this is just a line normal halfway through this line. And this is just showing you data from the tragus. So what I think is remarkable about this was all done holding pups by hand with a cell phone to take the pictures, mostly by herself because it was during COVID, so nobody else could be in the room with her. And these are her data from her cell phone photos. These are the shapes of tragus length in known age bats from the lab, and you can see that the pup's tragus doesn't get to adult proportions until about this stage when pups are making their first flights, their developmental milestones. How does a pup's vocal beam change with development? We've been studying this in the lab. Carl Lyons has been doing it, and I'll have some new people doing it. So we set up a microphone array in our behavior room, and you'll get a tour of this today. And bats can sit on this platform here, and they can be adult bats or they can be pups. Here's a picture. We do this work in collaboration with our colleague Lasse Jacobsen from the University of Southern Denmark. And so the pups or adults can sit on the platform, and then they're emitting calls. You see the bat's mouth opens up, chirp, chirp, chirp. And these picked up by this microphone, so we can measure the spatial extent of the sonar beam horizontally and vertically, and the sound pressure level. And when we do stuff like that, we can get data. So here's a 2-day-old pup, a 24-day-old pup. You can see the 2-day-old pup is emitting its isolation call. It's used to attract its mom. And these are the echolocation calls of the 24-day-old pup. This is the same animal. And here's what the sound pressures look like for these different calls and the beam shape. And it's all normalized onto the central axis. So this microphone right here at the center. There's microphones here and microphones here. And you can see the sound pressure level falls off as the sort of the pressure to the side of the animal. But you can already see that the yellow dots extend more, they're wider out versus the purple asterisk, which tends to be more focused. And this is only at 24 days old when the animals still aren't even flying. So the idea is we think that the pups are learning to control their sonar beam and focus the beam. So they can focus it and aim it at targets, because then they can move their heads, of course, and focus on a target here or focus on a target there. And each one of these little contours is a halving of energy. So you can see the energy is halved already at 30 degrees relative to in front of the animal. So again, just like eyes, we're binocular creatures. We see straight ahead best, but bats are also seeing with their ears and the forward direction best, and they're getting less echoic information from the side, which actually might be an advantage. You don't want to have a bunch of clutter coming into your auditory system. At what age do pups begin to perceive target with echolocation? Stay tuned because I don't have any answers for you at this stage. All right, I want to say thanks to everyone because it did take a lot of people to produce this work, and I'm happy to take any questions. And here's a beautiful picture of a lactating female big brown bat that Brock took in the field during COVID when we were doing a filming with W5. Thank you.
Can't both be on, I guess. Okay, so I'm Derek, by the way, moderating this session. We do have time for some questions for Paul. And if anyone wants to special request more bat noises, he'll be performing all day. Caleb. Oh, sorry, before we do this, I just want to say for the live stream, the people on the live stream can't hear you unless you speak into the mic. So for presenters, when someone asks a question, we're just going to repeat the question into the microphone. So, okay.
Do I have an interpretation for the U-shaped curve? Yes. So the sensitivity is that the lower the values, they're more sensitive. So hearing thresholds are highest, you're least sensitive at the ends of the frequency range. So low frequencies are where the bats are least sensitive, very high frequencies, and then they have, there's some variation, of course, but that's their sweet spot. And it turns out in the big brown, that's right in the 50 to 25 kilohertz, the fundamental portion of their FM sweep, the frequency modulated sweep. Sorry, I'm using jargon.
Questions for Paul?
In the back.
Loud, please.
You had mentioned that big brown, like the lactating mothers, their calls will change after they pop. Is there a reason why their frequencies change? The calls change?
The pups' calls are, as the question was asked about the change of the calls of the mum, I think is what you asked. So the mums may change types of vocalizations that they produce when interacting with their pups. That's not what was shown here. I was showing you the change in the call of the pup as it's developing. And they switch from using multi-harmonic, long-duration signals to using much more, with a lot of just constant energy at every one frequency, even though there's lots of harmonics. Then they tend to switch to using frequency modulated, sweeping high to low in frequency, because that's what they use as their chirp for actively echolocating and perceiving targets in the world. Does that make sense? Thank you. Christy.
What percent of the time do your mothers give birth to two young versus one?
Thank you. That's a great question. So most of the time, the bats that we work with give birth to twins, and they are fraternal twins, although they could be identical. But we know that from field work that they can often be sired by different fathers too, the twins. Now, that's a genetic thing because most of the big browns east of the Great Divide give birth to twins, and west of the Great Divide, they give birth to single pups. And it's very, I've caught bats in North Carolina and brought them to Seattle, and they still give birth to twins.
Any other questions? Okay.
Thank you.
All right, thanks very much to Paul. So that was a great way to kick off our conference with the host and a great presentation. Now we're actually going to move on to a former student of Paul's. So we're going to hear from Lucas Gravel, and he's going to talk to us about flight energetics of temperate bats.
You want to do just a quick reminder?
Oh, sorry. Also, quick reminder for people to please mute your cell phones so that we're not disturbed through here. Just has to be said at some point. And sorry, just one second. So just don't go too far left. Oh.
Perfect. Cool. All right. Good morning. Thanks for making it out early. I know bat people aren't morning people, or most bat people. Today I'm going to talk to you about some flight energetics of temperate bats. And this is some work I've been doing as a postdoc in Liam McGuire's lab at the University of Waterloo. So to start, I want everyone to think about running a marathon. Okay? Think about standing at the start line, the gun goes off, If you're like me, you're probably going to sprint out, be a little too ambitious, maybe overestimate your abilities. Then over the next minute or two, you're going to set into a nice steady state run, right? Something that you're more comfortable running a longer distance on, a pace that you can maintain, and something that your body can maintain as well metabolically, okay? Now, I'm sure you're also sweating because the idea of running 42 kilometers is a little scary. But this here is Kipchoge Eliud, who I think should be considered the fastest man in the world. These are his split times for the marathon. He's the marathon record holder. He's running 42.195 kilometers in 2 hours and 1 minute, just under 3 minutes a kilometer, sustained at just under 3 minutes a kilometer, sustained for 42 kilometers, right? To me, this is outstanding. This is the fastest man in the world. No one else can hold this pace. Okay? But what I want to focus on is this first split, and this is for 5 kilometers. But I want to think about what's happening with his body at the start of the race. Okay? He's going to be going out from a standstill. You've warmed up, you've jumped, done your little feet kicks, you've looked like a pro, all fancy. But you're coming from a standstill. You're going to start running, and then you have to get into that pace, right? And we can start thinking about what's happening metabolically. What fuel source is fueling his running? So these are Kerr's standard of mammals for 2 different metabolic fuels. The top here we have lipids, and the bottom here we have carbohydrates. You look like a pro. On the x-axis we have the exercise intensity. So you can think of 100% as your full out, the maximum exercise, the maximum intensity that you can be holding. And here we have the proportion of fuel sources. And this is standard of all mammals, and it's going to be true of Eliud as well here. At the start, when you're at your maximum energetic intensity, when you're starting out, you're sprinting, you're going real hard at that start, you're going to be fueling this exercise mainly on carbohydrates. But you can't use carbohydrates for high intensity exercise over long periods of time. As your exercise, as you go on and you're not at your maximum anymore, you start to use lipids. Okay? Your carbohydrate usage is going to decrease because you can't sustain that high intensity exercise for 2 hours over 42 kilometers. So what's really amazing when you look back at these times is you can actually be running this marathon at full intensity. This is more like a great jog for this man, which makes it even crazier that he's doing this jog in 3 minutes. Okay? Now, when we talk about mammals as a whole, there's 3 main fuel sources that we can be talking about. And I just introduced 2 of them, the carbs and the lipids. And the carbohydrates are going to be fueling this high intensity, short duration exercise. Okay? Carbohydrates are really low in energy density. We burn through them as mammals really quick. And once those reserves are gone, we got to switch over to our lipids. Lipids are going to fuel more moderate intensity exercise. You can hold this for longer durations. They're much more concentrated in their energy density at wet mass and at dry mass. And this is really what's fueling that long duration exercise. So things that when we're going for a run, when we're going for long swims, when you're playing that long volleyball or tennis game, match. And in emergencies, we resort to proteins. Okay? We don't use proteins. They're really more of an emergency reserve. In order to get proteins from the body, you got to start breaking down tissues, muscle, and your organs. Okay? So this is great. We know this works. But the question starts to get trickier when we start talking about bats. Okay? Bats are, of course, the only group of mammals that are going to be flying. Flight, we know metabolically, per unit time is the most energetically costly form of locomotion. And bats have to fly at high intensity, always. You can't slow down. Okay? I should have thrown it up here, but we know that as a bat is a flying animal, as they slow down in their flight speed, it actually takes more energy for them to stay flying. Okay? So they need to stay at this high intensity. Going down to this moderate intensity isn't an option. But they're also going to be running out of this fuel source, these carbs, real quick. So obviously bats are doing something a little bit different. And if we look in comparative studies and we go over to birds, we know that birds fuel long duration flights on lipids. They're using the high intensity exercise to be fueled by lipids in this other flying animals group, taxa. Okay? So maybe bats are doing something similar. This here, just to give you an idea of this flight that's fueled by lipids, is the bar-tailed godwits. Going to fly from Alaska down to New Zealand, 9 days, non-stop flight. And they're fueling this basically on lipids. So we're starting to study energetics in animals, and particularly in flying animals. There's a number of methods that can be used to study energetics. One is doubly labeled water. I'm not going to get into the details, exact details of all these methods, but the idea with doubly labeled water is that you're going to need to inject an animal, recapture it 24 to 48 hours later. So you can imagine everyone here who's caught bats going back and trying to catch that same animal 48 hours later to get another measurement reading. Not the most practical for bats. And you're also going to get a field metabolic rate. So this isn't just looking at the flight periods, but also the inactive periods, the active periods, the grooming, allogrooming, all the movement, walking around within a roost. So for us, looking at flight energetics, not the best. You can use respirometry as well, classic flow-through respirometry. You need to have an animal in a chamber, and you can only be getting a metabolic rate at that time. You can also use masks. For a bat flying around with a mask on its face, not the most practical, although people have attempted it. And the method we're using is the 13C bicarbonate method, which I'll explain a little bit more in a second. Basically, we get nice washouts within hours, right? It doesn't affect the animal long term. You can reuse the animals over successive days because it's minorly invasive. Yeah, and the biggest part, though, is that you can get a metabolic estimate with the animal being unrestrained. So for studying flight, it's a great method to be using. So the bicarbonate method has been used in bats before in other studies, largely by Christian Voigt's group out of Germany. So this is just one example of some metabolic flight data. This study was looking at the cost of rain and bats flying in rain. So on the x-axis here, you have dry animals that were wet, but it wasn't raining while they were flying in this experiment, and then wet and rain, where they simulated rain, the animal was getting wet as it flew. And basically we have the metabolic rate, and we can see that when the animal's wet, it increases their metabolic rate. Okay? Likewise, here's another study looking at the cost of flying during the day, right? And they're talking about the body temperature of the animal heating up, having a higher metabolic rate when it's flying during these light periods and these warmer periods. And basically just the metabolic rate is going to be increasing during the day. So these are just a couple studies that have looked at flight energetics in the past using this similar method. The big thing with these studies and a lot of studies with bat flight, they occur over 1 to 2 minutes of flight. I don't think I need to tell everyone here that bats can fly for more than 1 or 2 minutes, right? And this is where we start to think back to that marathon question. What's happening at the start of the marathon versus once you get into that steady state activity, that steady state exercise? Something probably a little bit different than what's happening in these first 2 minutes in these flight experiments. So we wanted to use the bicarbonate method to get into asking these questions about longer duration flights. So this bicarbonate system runs on the natural buffer pool of the body. We're going to talk about this real quick. We don't have to understand it super intense physiologically. But just to give a quick refresher, we know that energy is metabolized. So in this example, this is glucose metabolism. And basically, for all the oxygen we take in, that's a big error. That's oxygen. There should be a 2. We have 6 CO2 produced. Okay? And when the CO2 is produced with water, carbon dioxide, water, form bicarbonic acid, and we don't want acid going through our blood system, so it's quickly converted to bicarbonate and proton, which is picked up by our hemoglobin. The idea here is that bicarbonate and CO2 are constantly in flux, right? They're in nice equilibrium and in our body going back and forth. And that's the basic idea I want you to take away right now, and I'm going to show you some nice data that when we inject animals with bicarbonate, we can measure their CO2. Okay? So for these experiments, we're using wild bats from southern Ontario, caught a handful in Aberfoyle, Ontario, and then a handful caught in a variety of different buildings on McMaster campus. So these are all wild caught animals. They're not escapees from Paul's colony. They are wild animals. Paul was generous enough to let us hold them in a facility here for the duration of the experiment. And what we do with these flight experiments, at the start, we inject them with 13C bicarbonate, right? So heavy bicarbonate. Sorry, I should clarify with 12C. Oh, I'm out of the camera, sorry. With 12C being the more prevalent isotope. So this here we're labeling it with the unprevalent isotope and look at ratios, right? So sorry, I should clarify that. We then put the animal in a respirometry chamber. We're able to look at their isotope analysis, get some data. This is all from their breath. This is all the CO2 that they're breathing out. We're then able to fly the animals for 2, 5, 8, or 11 minutes. So those past experiments, I said, they're all looking at 2 minutes flight, roughly. We're trying to extend this out to longer periods of flight. Then we're able to look at their isotope analysis afterwards as well. So this is me. I've set up a little makeshift lab in the back of a building here on Alumni House at McMaster campus. You can wander over if you wish in the rain afterwards. The lab is not there anymore, but you can still wander over. So this is the building. We got our lab set up in this little garage. Alumni Services was super generous with us, and we hung out there all night. Here's a little greenhouse we set up to be moving animals in and doing injections in, so they're not just out in the garage. And we're able to use a little gazebo at the back, 15.5 by 15.5 gazebo, to fly these animals. We lined it with vapor barrier to prevent animals from landing. They just keep flying and flying and flying. It's a beautiful, nice place to hang out there at night. Lots of wildlife. You have deer, raccoons, skunks. Sometimes you find the odd intoxicated undergrad. But yeah, so we were out here from about 7, 8 o'clock when sunset was happening out to about 3, 4, 5 a.m. depending on the night. So hoping this works. You can see that we got a bat here flying around, and these bats will just fly. They go around and around. The one bat flew for a solid 11 minutes straight, but it works well. They don't like the vapor barrier. It's too slippery for them to land on and actually get into with their claws to hold. They just fly in circles. This is I mean, it's beautiful when you stand there and you're watching it. It's majestic. If you have the volume on, you can hear myself and Jod Hughes here helping me outside the gazebo going, I'm so proud of him. He's beautiful. It's so majestic. But the bats fly around. And then this is what we're doing right afterwards. We're putting them right back in that respirometry chamber. Basically, with that isotope, you're going to see when we inject them with that bicarbonate, the CO2 ratios in their breath is going to peak. And it's going to decay nicely. This big gap is where we're taking them out and flying them, and then we're able to get an isotope ratio after. You can imagine if they didn't fly, this would decay nicely, but instead it's moving, the curve's shifting down, and we're able to do a bunch of fancy math, put it into R, say a few cuss words, yell at my computer, do a little bit more statistics, and in the end we get one nice, beautiful graph. So this is hot off the press this week. This is basically our raw metabolic rates in the volume of CO2 produced. And we have our flight durations here on the x-axis. This isn't accounting for yet body mass of the animals. We had a repeated measure design. Animals do sometimes flutter down to the ground, take a little bit of a break. We haven't accounted it with those videos for all those little breaks yet, but this is the raw data. And some of the big stuff we can see right off the bat is a decrease in the variance of the metabolic rate over longer durations of flight. To me, this suggests, kind of like that marathon, that we're starting to get into a more steady state flight, and the metabolism of these bats changes when we start looking at flight durations outside of this 2-period range. The other thing we can be doing and look at, and I talked about before, is this lipid versus carb question. I don't have data on that yet. I worked my ass off this week and I didn't get it for you, sorry. But we do have the data to get that information. And what I'm going to suspect is at the start here, the bats are using carbohydrates. And as we get into longer duration flights, they're going to switch over to lipid usage, right? And already we know that, you know, with the CO2 output, you're going to be outputting less CO2 when you're using lipid metabolism. This decrease here is kind of starting to suggest that already. So some things we can be doing with this flight research in the future. We can look at the fattening of bats prior to hibernation. How is this going to be impacting their flight? right? You ought to get fat, but obviously at a certain point you can't get fatter or you can't fly, right? Offspring overload. These bats are also be flying around with pups 30% of their body mass, okay? And we can start looking at ratios and radio tags, revisiting that 5% rule, and we can look at it from an energetic cost, an energetic perspective. How much does a little bit of variance in that radio tag we're putting on an animal actually influence its energetics? So these are all questions we're going to go forward through in the future, and I'm going to keep pursuing over the next couple of years of my postdoc. So I just need to thank everybody, Liam McGuire, my postdoc supervisor, Jod, who is a master's student at McGill, and Paul, who's let us use this colony, and everyone else. I definitely need to thank Gwyn and Lily, who came out and helped me catch these animals, and Shane and Kazuma, who would text me in the morning and be like, don't worry, I fed your animals, don't rush in, and let me get a couple extra hours of sleep on those like late night mornings. Thank you.
Okay, oh, there we go. All right, so we are running a little bit behind time, but we can have one question for Lucas. Any burning question up? Okay, we have one.
How did you select the flight durations? And what's a typical, what is the thought of a flight direction or flight duration for whales?
So how do you choose the flight durations for a study? Honestly, we're going off 2 minutes for past studies, right? And then we're trying to increase into longer duration flights. We said, you know, if we had a couple minutes, it might be at that real border between what we expect for carb lipid, and then we just wanted to get into what would be a longer extension flight. So we got up to like the 11 minutes. So there's some guesswork in there, just going nice intervals, but we're building off those old studies at 2 minutes. Some of those studies looking at the carb lipids there are suggesting that they're still using carbs after those 2 minutes. So we just really want to make sure we hit that transition period in the position, in the time periods afterwards. In the wild, man, they can fly, but like for time, for distance, they'll fly for half an hour easy. I mean, I want to say hours, but I can't give you a study if you ask me that said, oh yeah, they tracked this animal 4 hours. But they 10 minutes is not a problem for them. The bigger issue with any of these longer duration flights is that you reach the time where the animal tells you to screw off. I can't get out of here, as opposed to any actual fatigue for the animal. Thanks.
Okay, we're coming back to the Bat Lab at McMaster for the next one, and we have Shane Sewell presenting on efficacy of subcutaneous P-chip implantation in the wing and leg of big brown bats.
Hello, hello. Oh, okay, great. Hello, everyone. My name is Shane Schwelt. I'm a graduate student in the McMaster Bat Lab, and today I'm going to introduce a new mark recapture technique to you known as the P-chip tag. And I did a little preliminary study testing its efficacy in big brown bats. So first, I want to talk a little bit about marking techniques. There have been many marking techniques used in bat ecology research, and of course, the need for these marking techniques is because some bats lack distinctive features, right? We want to be able to identify the bats that we catch and re-identify them when we catch them again. And there have been many marking techniques used in bat ecology research, including radio transmitters, freeze branding, bead necklaces, toenail painting, punch marking, and if you get a chance to tour our captive colony here at McMaster University, you'll see that we both band and use passive integrative transponder or PIT tags in our bats. And despite noticeable differences between these marking techniques, they all serve the same general purpose, as I mentioned, to distinguish marked animals. However, no one technique is superior to the others. Some come with pitfalls, right? Some have been shown to affect flight mobility, some have been shown to affect foraging behavior, and some have even been shown to cause injury as well as morbidity in bats. So today I'm going to introduce a new mark recapture technique known as the P-chip tag, which is a 500 by 500 micron semiconductor tag that can be implanted subcutaneously in bats. And the way that this tag works is once you apply a laser beam light to the dorsal surface of the tag, activating the photocell as shown here, a radio frequency signal with a 9-digit number can be sent as a radio frequency signal back to a sensor wand. And this 9-digit number can then be read through a software and recorded. So we wanted to see, does this P-chip tag work as a viable marker for use in bats? We wanted to see if its efficacy compares between two implantation locations, being the wings and legs of bats. And we wanted to see if it has long-term potential for use as a marking technique. And to do so, we conducted many recording sessions, and most notably one a year post the final recording session. So as you can see, we implanted these P-chip tags subcutaneously, both in the wings and legs of big brown bats. And despite their very miniature size, they're somewhat visible, as you can see here in the wing and here embedded in the leg, as emphasized by these white arrows. And now, I want to note that the handheld laser wand used to scan P-chip tags constantly emits a laser light. As you can see here, scanning a P-chip in the wing. But once these P-chips are sufficiently activated, you can see a stronger emittance of light, suggesting that the P-chip tag has been sufficiently activated, and thus you would get a scanning of the 9-digit serial number. So for this project, we designed a protocol to scan and record these P-chip tags within the bats, which involved both a handler and a recorder. And the handler's responsibility was to manipulate the animal, expose the P-chip tag in either the wing or the leg location, and use the scanning equipment to scan the tag. Whereas the recorder was responsible for recording any parameters and handling the time. So a given trial would start a bat out of a cage, where the recorder would then press start on a timer. The handler was responsible for opening the bat, held wand when they were ready, when they exposed the P-chip tag within the animal. The handler would then orient the bat to try and the scanning equipment to try and expose this tag and scan it. And once they achieved a successful scan, the timer would stop. And as I had mentioned, we had 11 recording sessions, most notably the yearly follow-up on day 464 after the prior recording session. So first, we recorded handling time, the time taken from grabbing the bat out of the cage to achieving a successful scan. And as you can see here, we have average handling time over the duration of the study for both P-chips embedded in the leg and in the wing. And as you'll see, as for the rest of the figures in this presentation, the yearly follow-up in a panel on the right side here. And as you can see, the average handling time stayed fairly consistent over the duration of the study for both P-chips embedded in the leg and the wing. However, bats were handled for longer when recording P-chips in the leg versus P-chips in the wing, suggesting the wing might be the preferred location for P-chip tag implantation. We also measured scan time, which is the time duration between grabbing the handheld wand and achieving a successful scan. And as you can see, we have average scan time over the duration of the study for both implantation locations. However, scan times didn't differ between the two implantation locations, except the variance associated with scanning P-chips in the leg did tend to increase. And there was actually somewhat of a trend of increasing for both P-chip implantation locations, which was surprising because you would think with practice effects, using the scanning equipment more often, that scan times would decrease. So this was somewhat of an interesting find. We also measured P-chip visibility as the subjective judgment of viewing the P-chip tag using a yes or no scale. So did you see the P-chip tag while you were trying to scan? And as you can see, the proportion of visible P-chips remained fairly high for P-chips embedded in the wing, although it did decrease over the duration of the study. However, the proportion of visible P-chips in the leg was fairly consistent, about 50%, but always remained less than the visibility of P-chips embedded in the wing, which is somewhat interesting. And this may be due to the ease of seeing P-chip tags in the wing, right? We're much more used to opening the wings of animals and seeing very clearly through the translucent and hairless skin, as opposed to in the tibia where it may be hidden by the calcar or the tail of the animal. We also measured handheld wand flashes. So I had mentioned to you that once you sufficiently activated the P-chip tag, a stronger emittance of light would occur and a successful read would be taken. But we noticed while we were recording that these strong emittance of light would occur without a successful read of the 9-digit number. And we termed these as flashes, right? So when the handheld one would emit a flash of laser light, but no successful read was taken. And as you can see, the average number of flashes decreased for both implantation locations, but there was no difference between the two implantation locations. And this, again, suggests that practice effect, right? As you become more proficient with the scanning technique and you get used to the location of the P-chip tags, it gets easier to scan without these handheld wand errors over time. And lastly, we measured unreadable P-chips, which were defined as P-chips unable to achieve a successful scan within the maximum allotted time of 2 minutes, 45 seconds. And I think it shows pretty clearly that the wing has 0 instances of unreadable P-chips, suggesting it might be the preferred location for P-chip implantation, whereas the proportion of unreadable P-chips in the leg started off at about 30% and increased over the duration of the study. So what did we find? Well, the P-chip tag seems to be a viable marker for use in bats, right? We were able to record these P-chip tags and achieve successful scans. As you can see from the data, the wing is the preferred site for P-chip implantation and scanning as compared to the leg, as borne out by the data. And through those yearly follow-ups, we found that the P-chip tag does have long-term potential for use in mark recapture field studies in bats. I'd like to thank everyone in the photo, as well as Dr. Bennett and Dr. Alex Borisenko, as well as my supervisor, Paul Four, and everyone who has helped with the P-chip project along the way. And I'd be happy to take any questions.
Okay, we're right on time, so we already have some questions.
How does it compare cost-wise to, let's say, pit tagging?
Great question. So you want me to repeat the question? Yeah. How does it compare cost-wise to its alternative pit tags? It's comparable to the price of pit tags. However, typically a pit tag, the tag itself, will cost about $5 to $8 USD, whereas P-chip tags cost about $2 USD each. The problem is with the scanner, and the scanner comes from a sole corporation known as P-chip Corp, and it costs about $2,000 to get this scanning wand, whereas typically for pit tags it costs about $1,500 anywhere to $1,800. So it's very comparable to pit tags.
I may ask my follow-up question?
Sure.
Sorry. So I'm a wildlife facilitator. We currently scan bats for chips. That's going to be a bit more problematic if that gets used, on a practical basis, because we don't have $2,000 to buy a scanner. Any thoughts on how to circumvent that?
Sorry. Yeah, so the question was for a problem to circumvent the $2,000 price for the scanning wand. And that I'm not sure. I mean, as I mentioned, it comes from a sole source, the P-chip Corp. I'm sorry, I don't have an answer to that. I'm not sure.
Okay, any other questions? Liam?
Neat stuff here. That's really cool. I'm curious about the visibility section.
Sure.
So you had clear, better visibility with the wing than the leg. I wonder, did you ever have any naive evaluator, somebody who didn't know that there was definitely a P-chip here to find? As in, like, if somebody was marking them and I was to catch a bat, and if I looked at the wing, would I be able to find a P-chip, not knowing whether or not there was one there to find?
We haven't yet tested that. That would be really interesting to test, I agree. This was all done during, I'm going to pull the COVID card, so we weren't allowed to have a lot of researchers in the lab, but it would definitely be interesting to see if visibility, because you might not, as you can see through this picture, although they are somewhat visible, you're right, they would be hard to find, especially if you weren't looking for it. So it would be interesting, yeah, I agree, to see if a naive person. Yeah.
Okay, we have another question.
How close does the scanner have to be to the chip to read it?
Yes, so the question, how close does the scanner have to be to the chip to read it? So the scanner actually has to be fairly close, about 8 millimeters towards the chip. And as I mentioned with those handheld wand flashes, it could be dependent on the angle of the scanning wand. So you want to get the angle and the proportion and proximity just right to get a successful scan.
How close do you have to be to the pit tag?
Yeah, so pit tags can range. There are many different models for pit tags. Some allow for a larger proximity compared to others. I think the ranges are anywhere to 140 or 150 millimeters away. So it is very close, and you do have to get very close to the animal compared to pit tags. But people have also, or researchers have also used pit tag arrays that allow for greater proximity too.
There's a new one, the rates will be double that.
Yes, there is a new one. I'm not sponsored by PChip Corp, but there is a new one coming out that offers a greater proximity range. So they are addressing some of these questions.
Okay, well, I guess we have one more minute here, so we'll let Michelle ask a question.
I was just thinking about the comparisons of the pit tag versus the PChip. Is there like a longevity on that photo cell that's inside it? Does it last a certain amount of time?
So from what I know, and according to the PChip Corp, the photo cell doesn't really die off is meant to last for a long time, and is meant to withstand things like thawing and recooling and all sorts of things I can't remember. Sorry, off the top of my head. But yes, it is meant to last for a long time.
The lifespan of that.
Yeah. So typically these PChip tags are used for marking jewelry, and they've also been used in mice and honeybees. Yeah.
Paintings, art?
Yeah.
So we are actually ahead of time by 5 minutes. I'm not going to make Shane answer any more questions, and I think Paul will buy everybody a reader in the room. Maybe not. Okay. But we're gonna delay and take a breather for a couple minutes. The only reason for that is because some people online are kind of following along with the time and they want to chime in. So we're gonna give everybody a little bit of a break, and we'll start again at 10:10. Right? 10:10. Okay. 2-minute warning, everybody. Come on back in. And everybody in the hall. Thirty-second warning. There's still people in the hall? Okay, let's get going again here. Oh, there's still people filtering in. Okay, we're not waiting too much. We're going to dim the front lights here again. Okay, welcome back, everybody. We had an extra break there, but we're going to get back at it here. We've been learning lots about bat work in the lab, and now we're going to finally get outside with some fieldwork presentations, and we're going to start that with a presentation from Christy Humphrey, and she's going to talk about eastern small-footed myotis on the Niagara Escarpment.
Thanks, everybody. Very happy to be here. I am going to speak a little bit about some research that we did a little while ago. So this was back in 2016 and 2017, but I'm presenting here today because I realized that while I've presented at a few events in, how do I work this?
Click left or right.
Oh, great.
There's your pointer.
Okay, thank you. While I presented this information at a few events based in the US, I have never actually presented this information in Ontario. So please excuse the delay, but I haven't had the opportunity really until more recently. So yeah. So eastern small-footed myotis, as we know, was listed as endangered in Ontario in 2014 due to white nose syndrome. The recovery strategy was worked on between 2015, 2016, and finalized in 2017. But when we're sort of working on that, things that we need to talk about in the recovery strategy, how do we recover a species at risk? We need to understand what its distribution is, population sizes, and habitat. Where is its habitat? A big part of the recovery strategy is developing an area recommended for habitat regulation, and you can't really develop that unless you know what its habitat is. So for this species, we really knew very little about where it was roosting before preparing it, the recovery strategy. Some recent information out of the US had started to indicate that the species was probably roosting in rocky habitats, open, sunny, rocky habitats. But we didn't have any information like that in Ontario. So that was a really big, important step to try to doing some work to find out where the habitat for the species is in the province. So I don't need to probably say too much about the Niagara Escarpment in Ontario, but as we know, it's a very prominent feature that contains cliff and talus. The more prominent cliff and talus locations are sort of the Bruce Peninsula and then down around sort of the Halton region, I would say. And most of our talus is not open, right? Most of the talus is pretty treed, but there's some small areas of open talus as well. So in 2016, we carried out a primarily acoustic study. We wanted to know, is small-footed myotis using cliff and talus habitats on the Niagara Escarpment in the summer specifically? So along with the other species, we do have records of the species hibernating, at various hibernacula throughout the province, including hibernacula on the Niagara Escarpment, but really didn't have any summer records, especially maternity records. And if so, if they are in these areas, are there sort of seasonal patterns in that activity that we might be able to detect from acoustic surveys? So acoustics were the answer for that. But then the other question, because as those of us who do acoustic monitoring know, differentiating various myotis species acoustically is very challenging. So in order to just sort of verify, is small-footed myotis actually at these sites, we did some capture surveys as well, just to confirm that. So we had 3 study sites. The first site was a natural cliff and talus site on the Niagara Escarpment, on the Bruce Peninsula specifically. The second site was another natural cliff and talus site in Halton region. And the third site was actually an abandoned quarry with, so it has these cliff faces from excavations and sort of this makeshift talus slope made up of large boulders. So for our capture surveys, as you can see, our acoustic detectors were on poles in these open talus habitats, trying to minimize clutter as we can, as much as we can, in the little pockets of openings. And the netting, we did net directly on the talus slopes in 2016. We mainly put our nets in between patches of vegetation. There wasn't really any overhanging vegetation that we could take advantage of. Certainly there's no puddles on a talus slope. So we netted directly on the talus with the net as close to the ground as we could get it, and between the patches of vegetation. The reason why we wanted to net directly on the talus too, part of that reason was because Dr. Paul Moosman in the US, when he had been netting on talus slopes, in habitats that contain maternity colonies, he would net on the talus slopes and capture eastern small-footed myotis that way, and found that to be effective. So we wanted to do the same thing. And our nets were essentially parallel to the cliff or V-shaped. We tried a couple of perpendicular to the cliff nets and just never really caught anything, so we just stopped doing that. So for our first site, we did 4 survey nights and we caught 3 bats, and all 3 of them were eastern small-footed myotis. So that confirmed a new site for them, which was great. Acoustically, eastern small-footed myotis represented only 2% of auto-classified calls, and small-footed myotis was most abundantly classified in May at this site. At our second site, again, we did 4 capture survey nights. This site, we caught a lot more bats. We caught 13 bats, and 7 of them were eastern small-footed myotis, so over half. We also captured little brown myotis and big brown bat. So this was another new site confirmed for the species, and part of the reason why we caught so many bats was because there was actually swarming activity sort of happening behind the talus, between this talus pile and the cliff. So that was a new swarming site that we identified, so that was really great. In our acoustic data for this site, similarly, eastern small-footed myotis was 4% of all auto-classified calls. But in this case, they were most abundantly recorded in July and August, which sort of matches up with that swarming activity. And you can see that big brown bats really dominated the acoustics at this site compared to the Bruce Peninsula site, which was dominated by species at-risk bat calls. And at our third site, we did 3 nights of capture here. We captured 2 bats. Both of them were little brown myotis. So no eastern small-footed myotis were captured here at the abandoned quarry. One of the little brown bats was actually captured really low in our net and had a lot of dried mud on it, like dried dirt. So we suspect it was probably roosting in the rocks there, at least for a little bit. So that was really interesting. But at this site, Dr. Moosman had actually come out in the spring to do a little bit of a training session with a few folks on doing visual surveys, since that's the method that he mostly employs to monitor populations of the species in the US. And he had us sort of spread out and start trying to look in crevices. And it was really interesting because we were all trying to look in crevices, and then once Dr. Moosman got started, he like zeroed in on a crevice, went there, and there was an eastern small-footed myotis in the crevice. So he clearly knows what he's doing, and he has that visual search pattern like really nailed down. But our netting wasn't really effective here compared to the other sites, so that was interesting. Also interesting, in the acoustics, small-footed comprised 21% of auto-classified calls. So a much larger proportion of the calls than when we were netting at the natural cliff and talus sites. And they were most abundantly classified sort of more from May to about mid-August, which was interesting because there is a hibernaculum also very close to this area. So just, I don't know, interesting, I guess. Interesting to see those seasonal differences. So sort of recapping that, was acoustic monitoring successful, for detecting the presence of eastern small-footed myotis? Yes, but just because we had more calls didn't equate to more captures for us. And overall, we were thinking, wouldn't it be awesome if we caught an eastern small-footed myotis? And it turns out that it wasn't really that hard. Which is really great, but we just needed to net in the habitats where they're theoretically living, in these sort of challenging, difficult to get to places. And yeah, they were not easy to capture in the old quarry, obviously, but fortunately, Dr. Moosman was there, so we got that confirmed. So in 2017, we followed up on our acoustic work on eastern small-footed myotis by asking the question, where is this maternity and summer roosting habitat? And really the only way at this time that we can know for sure where roosting habitat is by doing a radiotelemetry study. But we also wanted to know, were visual searches helpful? Because they are helpful in the populations that Dr. Moosman studies in the Appalachians. Are they helpful for us here? Are they helpful to help find colonies? Could we use data from visual searches to sort of supplement the information we get from doing radiotelemetry? And are there other species roosting in the same area? Could we come across big brown bats or little brown bats roosting in the same places too? That would be interesting to know. And I'm just going to cut straight to our visual search results. So we conducted visual searches at our 4 study sites that we had in 2017, plus a bunch of roadside rock cuts. So we searched for 17 polygons, 37.5 hours, and a bunch of other unstandardized searches, and we never found any bats. So not super useful. Noting that when we're doing visual searches, we can only sort of do them in the places that we can reach. So on the talus and maybe the bases of cliffs, but what about all the cliff further up, right? We couldn't really reach any of that. So we repeated our capture surveys at the 2 sites where we caught eastern small-footed myotis in 2016. So yeah, the natural roost and talus sites, and we added 2 new natural roost and talus sites that looked promising, some more open, sunnier, rocky areas. This is one of our sites though, and so you can see here, like the cliff is pretty far away from where the path is. And I wasn't super excited about the thought of walking 300 meters in the dark over like no paths, over treed talus with boulders everywhere, lugging a bunch of equipment. So instead we netted over the puddle on the trail, which is, in general for any species, that's a great place to net. So we netted around 2 to 3 nights at each of our sites between May and August, and a little bit of extra netting with no radiotelemetry in September. In general, we didn't really catch much in the spring. We didn't really start catching anything until sort of late June. Overall, we captured 44 bats between the 4 sites, and eastern small-footed myotis was the species that we captured the most. Fairly low species diversity though, just also again big brown bats and little brown bats. Study site 4 is the same site where we caught the most bats in 2016. So we caught quite a few there. And you can see study site 1, we didn't capture any small-footed at that site. And that was a natural cliff and talus site again as well. But we did capture them at the remaining 3. In terms of composition, study site 3, which was a repeat, no, sorry, it wasn't. Yeah, study site 3 was a new site. 80% of the bats we caught there were eastern small-footed myotis. So how many eastern small-footed myotis do we capture a night? Well, it ranged from none to 2.6. So sort of on average, we got this sense and kind of bared out when we did the analysis that when we go out to try to capture eastern small-footed myotis in talus habitats, we generally can expect about 1 bat per night. So we applied the smallest size of transmitter that we could get from Hollow Hill to eastern small-footed myotis to try to stay within that 5% weight range that Shane mentioned. They don't make this transmitter anymore. That's because it requires really, really small batteries, and they have to buy it in bulk, but not that many people order them. And that did become a bit of a problem for our study, as we'll see. So we attached transmitters to bats at the 3 sites where we captured small-footed. That included 9 adult males, 1 lactating female in mid-July, which was exciting, and 1 juvenile male in mid-August. So where were they roosting? Some pictures of their roosting sites. They were roosting deep in crevices, high up, and out of our reach. So we didn't really confirm any, not any, but most of these bat roosts we couldn't visually confirm. Except for the juvenile male. In mid-August, we tracked the juvenile male to this large boulder, a crevice. You can see the large crevice in this boulder. And there's the little guy hiding out in the crevice. So mid-August, we can't really confirm that this is maternity habitat. It's a little too late, but it could be maternity habitat, as we know juveniles will hang around maternity sites longer than adults will. And certainly that could have been a maternity site, but we can't really say for sure that it was. Dr. Mooseman, when he saw the photo of this roost, said that that's the size of the boulder and, you know, the type of the crevice that he normally sees maternity, like females with juveniles in at his sites. So we can be optimistic. So in general, we were able to track 1 to 3 days per bat. And we got roosting locations from 6 of the 11 bats that we tagged. And we identified 11 roosting sites. So that's a little bit low, low even for radio telemetry. For 5 of our 11 tagged bats, we didn't get any roost sites at. And so speaking with Hollow Hill about how this went, and not being able to pick up any signals whatsoever from a bunch of our bats, and them cutting out, a lot of them cut out after 1 day or 2 days. That's the battery issue, so having to buy them in bulk, they sit on the shelf, not a lot of people buy them, so the batteries were probably quite depleted. So these things happen. In terms of our tracking results, here's one of our sites, and the pink lines represent the locations where we netted. This is my cottage. So up on the talus slope in the open, and then this male that we captured here, an adult male, roosted immediately beside our net location in the cliff. So 30 meters away on 3 different days. 30 meters away, but if you want to walk from my cottage up to where they were roosting, it's a 45-minute hike because you have to go around in order to climb up the escarpment. Yeah, especially here, there's 2 levels of escarpment, like the two different rock types. So yeah, to even get to the bottom of the cliff there, you have to walk 45 minutes around. This was the juvenile male from that site. Our net location's about 170 meters away, but you know, here's our one roost site where we found the boulder, and some, you know, our other telemetry points and triangulation. As you see, kind of messy looking. It takes a long time to walk all the way up to the cliff to take one point, and then, okay, well, now we've confirmed, oh, it is down there. Now we have to walk all the way around. That's a 2-hour hike. So it takes a long time just to go that small distance to try to find the roost site. Here's our one site where we netted on the puddle over the path. So again, they were roosting in the cliff, like immediately adjacent to where we netted, in this case, 300 meters away. So the male here is in blue and the female is in pink. And yeah, they're roosting in the cliffs again. This location was where we tagged the most bats. 6, I think, were tagged at this location, and we only had one day from one bat from this location. So yeah, you can see our net's 12 meters away. It was roosting literally right beside where we captured it. Again, it was only one day, maybe it was just a little traumatized, but similar to the pattern at the other sites where they're really just in the cliffs very close to where we netted. And this one's a little bit more of a mess. So these roost sites were 730 meters and 850 meters away from where we captured them. So this is the same cliff section as the lactating adult female, just further down the way. So some of them were a bit further from our capture sites, but again, we captured them, they were roosting in the cliffs in that section where we were. So in summary, for the linear cliff and talus habitats that we have along the Niagara Escarpment, the mist netting seems to be effective for capturing them, but we do have to be sneaky because small-footed are really good flyers. They fly low and slow, so they can more easily see the nets and avoid them. So we did have to be pretty sneaky with where we put our nets. We netted directly on the talus in openings between clutter and on puddles over nearby trails. And they roosted mainly in cliffs, but also in a talus boulder. And yeah, we need radio telemetry to identify this. We can't do this work without radio telemetry. And visual searches were not helpful. So we answered that question. Not in these habitats, right? They're roosting way up high. It's no wonder that we didn't really find anything when we were doing visual searches. And many thanks to the tons of people who helped with this study and the Ontario Species at Risk Stewardship Fund for funding the project. And extra special thanks to our field crew who did the radio telemetry, Kelsey Huffman and Lindsay Russidi. Did a lot of hiking, a lot. So thanks. Any questions?
Okay, we have 5 minutes for questions, so there's lots of time. Any hands? There's one.
Thanks, Christy. That was great. Really interesting. I remember watching the videos or like the presentation that Dr. Moosman made for, I think it was for MNR back in 2016 or whatever, and seeing some of the pictures of the talus and where he was searching and all the rest of it. I'm wondering, and it's probably impossible to answer based on the amount of data that we have, but I'm wondering if there's differences in where he was finding small-footed in the talus on the sites that he, does field work at versus the escarpment. So the talus is pretty limited, I guess, typically at the escarpment. Like there might be some big boulders, but it's not like spatially expansive typically. And then I don't know if at his sites there was like a big, basically rock cliff in front of the talus, and that might explain why the bats here, are finding in kind of safer places than being on talus on the ground. So just maybe any thoughts on use of talus in other places versus where you were finding them, which is in the actual cliff of the escarpment.
Right, so thoughts on differences between where we're finding bats roosting on the Niagara Escarpment, cliff, which is mostly cliff environment, versus Dr. Moosman's work in the Appalachians, which was sort of more talus, but occasionally cliff. So yeah, I think that's sort of the difference from what I've seen from the photos too. Their talus slopes are a lot larger, they're really long. I think they're sort of less associated with cliff and more just associated with mountain. I don't know exactly, but I know that he has described finding a lot of maternity roosts, like where one boulder is on top of another boulder, and like there's like a little crevice sort of like that. So it could be that, those talus slopes are composed of larger boulders that are making more of those types of crevices, whereas our talus slopes, where they are open, and not totally covered in poison ivy, where they are open, most of those rocks are smaller, right? Like, not all of the sites have the really large boulders, which are that dolomite capstone rock, right? The one site, I mentioned the 2 layers. The lower layer is like the small rocks, and the upper layer is the dolomite capstone rock that makes the big boulders. So I think we just have less of that, but we do have lots of open cliff. And again, I just wanted to mention too, these sites that we selected were all like south-facing open sunny, or south, they range from southeast to southwest facing, just to make sure they were getting enough solar. We didn't bother trying at any sites that were like north-facing, so they would have been shaded basically all day.
Any other? Okay.
Just a question about the acoustic side of the study. So I noticed you'd mentioned the auto classification. I was just wondering, was there a component of manual verification or, say, a screening out of calls based on things like being out of search phase or other things that might kind of mess with the data? I was just wondering what the process was, or whether that was just kind of outside of the scope of actions taken for this.
Yeah, so for that analysis, we looked at auto classification results just because it allows for a bit more standardization, and we had a lot of data from 3 season. It would be very time consuming, especially some of those sites like 64% of the calls are SAR. That's a lot of calls to have to look at, and a lot of them are just going to end up being like myotis or high frequency. So yeah, just looked at the auto classification for the standardization aspect of it. I can't remember if we actually did any manual vetting or not. Yeah, we looked at a few of them, but yeah.
Okay. We have 1 minute.
Just on the topic of the audio data, I was just kind of curious what kind of range you think you were able to get from your equipment, especially with like different source levels and different bat species. What do you think the area you were able to monitor with per site?
With the radio telemetry?
No, the audio.
Oh, the audio acoustics. Like the range around the microphone?
Yeah, like how far away were you able to? You think you were able to pick up these bats? Do you have any idea?
Yeah, I think it's like it would have been fairly standard for all of the mics that we use in acoustics nowadays. So these were Wildlife Acoustics SM4s that we were using with U1 microphones. So there's a large debate about what the distance is, but depending on the day and the weather, 15 to 30 meters maybe.
Just remember the question for the people online.
The question was, how far away from the microphones do we think that we were able to pick up with acoustics?
Okay. All right, I think we're done. We're out of time for that. Thank you very much, Christy. So we're going to go into our coffee break now, but I just wanted to make one announcement. So the bat tours of the colony for the lunchtime are now full, but we're adding more tours at the end of the day. So if you didn't get into one of those tours, I think Nicole at the top is who you want to see, and she will help you find a spot in one of the other tours that's being offered later in the day. So get in on that. And okay, so we are going to take a break now. We will be coming back at 10:50.
Take your seats. Welcome back to the second session of our meeting today. I'd like to introduce our first speaker of this session, Sarah Larson. Sarah did her undergrad at UBC and is currently doing her Master of Science at Carleton in Christina Davies' lab. And her presentation is going to be about little brown myotis roost selection and movement patterns following an eviction. Welcome, Sarah.
Sorry, can we? They can. I don't know how to actually fix that. Because they can. Right here? Better? No.
If you go to the three dots, you should have a switch.
Sorry, this one? Hi, presenter view? And which one?
Sorry, no, up there.
Yeah, okay, no,
High
worries.
presenter view?
Are you seeing the presenter view in that laptop?
Right there, I think, display settings.
Yeah, but it didn't have the option to swap.
Okay, I can kind of wing it. It's all good. Let's go presenter view and I'll wing it. I've given this presentation 7 times. Okay. We're just going to wing it. You got it. Yeah, I've given this presentation a few times. So, hi everyone. My name is Sarah Larson. I'm a first-year master's student at Carleton University under Dr. Christina Davy, and we've been working on this project for over a year. It's actually a different project from my thesis, and it's on behalf of the Canadian Wildlife Federation. We're looking at how little brown myotis respond to a roost disturbance. So unfortunately for bats, and as we all know, they don't really have the best PR team, especially when they're in your home. And, you know, most people, when the public come into contact with bats, they are concerned about disease transmission and, you know, the restoration costs of their property if that's becoming a problem. And the public seems to always be worried about their hair. Don't know why. Little brown myotis are gregarious roosters, and they use a wide range of roost types. In attics in their homes, bat boxes, chimneys, as well as natural roost sites, caves, and trees. They can be quite problematic as guests, as we just said, and a lot of times people will choose to call pest control companies to get rid of them. We were really lucky that the homeowner of this project that we were on wanted to remove the bats as humanely as possible and decided to call in CWF, which gave us an excellent opportunity to study what their movement patterns would be after the disturbance. Additionally, we know little brown myotis are endangered under the Species at Risk Act, and in order to protect them, we need to attempt to define what their critical habitat is so that we can protect it. So part of this project was just to attempt to define, you know, what is their critical habitat. So the objectives of our study are to characterize the roosting ecology of the maternity colony of little brown myotis following a major roost disturbance or eviction, to assess the use of the artificial roosts that we placed to see if they're using them and the frequency of the uptake of these boxes, and to also look at the roosts that they are using after the eviction to see what kind of characteristics of roosts are commonly used by little brown myotis. So to reach our objectives, we looked at many different features of roosts and roost movements, and myotis-like movement patterns. So we wanted to know, does the distance traveled between their successive roosts after the eviction change after they're disturbed? We looked at the area of their roost networks, roost switching, and alternatively roost fidelity, which is them staying at their roosts for successive days in a row. We looked at for the roost boxes, we looked at the rate of occupancy or uptake. We analyzed different box dimensions that we placed, and different colors of the boxes, as well as the frequency of uptake. To characterize the different features of the roosts, we looked at roost types and materials, the heights of which the roosts were located, and their directional or cardinal aspect. So this is our study site. We ran the studies for 2 seasons, in August of 2021, and then again in May or the spring of 2022. In a rural southern Ontario property with plenty of forest cover here. You can see there's like a little river here, and there's quite a lot of lakes and wetlands nearby. This is just the study property here. You can see where some of the boxes are in yellow, and the buildings are, some of them you can't really see here. So unfortunately, the roost eviction became a attempted eviction, or more of a roost disturbance, when we realized that there were some entranceways into the old cabins that we weren't able to find. So this is just a small video of what happened after the eviction. Let me see if it plays. Here we go. So you can see there's some mesh right here. This is a bat box that was actually already located on the property. And you can see that they are not going into the box, but they are attempting to find a way in. And there it goes, back into the roost. It's kind of like, what? So there we go. So what did they do? So in the first year of tracking, we were able to track six tags after misnetting. I know this figure is pretty busy, so I'm going to go through it really quick. So here are the tags that we were able to follow, individual bats. This is their movement patterns here and their corresponding colors, just kind of where they went. And this is a farther range map here. You can see that one bat, it was a sub-adult female, went quite far before the disturbance actually, after tagging, and didn't return back while we were tracking. This here is the actual roost property, which I've blown up here in the map to the right. And so numbers next to each roost indicate how many days each bat was, or how many days each roost was used for, and this is the frequency of roost use. So you can kind of see these are larger, small dots and like a big dot. There was a lot of reuse frequency over here going on the property. We were able to track 3 adult males, 1 sub-adult female, and 2 adult females. 2 of the 3 male bats left immediately after the eviction, and we didn't hear from them again. Because of the timing of the season in August, we think they may have left for swarming sites. The females stayed, and roost switching increased after the disturbance. And I'm kind of forgetting some things here that I was going to say. I might just switch off my presenter view. There was some stuff I wanted to report. There we go. Okay, so I just really wanted to say some of these things. I don't want to forget them. So yeah, the females, one of the things they did is they regained entry into the old roost sites, and they kind of were flapping around and staying within quite a small path lengths there. So compared to the 4 days of pre-disturbance tracking, the roost switches increased. So the next year, we were able to track 9 bats, and they were all adult females. Judging by the time of year, it was a different season. So 5 of the tag bats actually dispersed immediately after tagging, and they stayed within about 7.3 kilometers of the roost. You can see like this range here. A lot of them were still using the previously evicted roost a year later. On average, bats exhibited less roost switching than the first year, and many stayed at their respective roost sites for the majority of tracking, and others actually stayed at their roost sites the entire duration and didn't move. So this light blue bat 114 and some of the other ones, 101 also stayed here the entire duration of tracking. There was a stronger roost fidelity when compared to the first year, and after the roost disturbance, the females actually had a lower reuse frequency than the previous year. And for bats that did switch roosts, their path lengths became larger than the first year, although there was a lot of variation in their path lengths, so we weren't really sure if they were going farther or if they were switching. With each switch, we're going farther. But over the 2 years, we were able to uncover 8 well-established roost sites, and 5 of which were large and frequently used, which was really exciting. So in terms of their network size, we measured that with maximum convex polygons, and the average roost network was in August, the first year after the roost disturbance, was just over 100,000 kilometers, which was like about 2.7 times smaller than in the second year. But because over the 2 years, we were able to uncover we actually expected sites, and 5 of which were large. Size of roost networks to probably be larger due to bats actually naturally going farther due to swarming season. We kind of expected that this area would be quite a lot bigger, so it was hard to tell if this difference in area was actually from the disturbance or for another effect of, season. So when we looked at roost types, we realized that the buildings and like anthropogenic structures actually were a really large part of their networks, which isn't really a big surprise. Buildings are in blue here, trees in green, and bat boxes in gold. So directly after, or before the roost disturbance, actually, we see that there is a little bit of bat box use here on the property. And then directly after disturbance, there were no bats found in boxes. None of our tagged bats used boxes. But we did see an increase in tree use. So they weren't really using a lot of trees. And then here they kind of, right after the disturbance, they started using a lot of the trees right on the property's perimeter. And what's interesting is that in the second year, we have no trees used. Maybe they're choosing buildings for their space, their thermal stability, their permanence, and using trees maybe secondarily. So teasing apart these physical roost features were really difficult, especially for little brown myotis, which are a bit of roost generalists. But what we did find were like some common roost type selections were southern and southeastern facing roosts. Roosts that are about 3 to 5 meters off the ground. We had a lot of roosts that were wood siding and tin roofing, especially when they were in attics or sheds. And the most frequently used boxes were often the largest boxes that we had that were painted dark. So this, it's hard to know if this is definitely the attractive features of a roost. However, there's some other work that's been done that says, they do like southern facing roosts due to a solar, like an increased solar warming period for those boxes, or the darker ones obviously have a larger heat capacity. But again, a lot of the roosts were on these buildings and they all had the same features, so it's a little hard to tease that one apart. But for our box uptake, we had some pretty exciting results. So we had relatively fast uptake of these boxes that we put up for mitigation purposes. I don't think I mentioned it earlier, but we had placed 4 different styles of box with different colors on 4 different buildings on this property as a mitigation tool. So I think I missed that when I was describing it, but we had done that right before eviction. We wanted to see, are they using these boxes? So right away here in the first year, you can see that we had I'm going to describe the figure. So we have date on the x-axis here and box frequency. On the y, each box is represented by a different color here, and then these numbers, I'm sorry if they're hard to see, that's just how many bats were in each box over time. So you see that they had some use, the attempted eviction happened, and then there was a time frame when none of the bats were using the boxes. they seem to kind of use a more distributed range of the boxes here, which was interesting. You know, maybe they were like exploring, but consistently they're using this gold box. It's box C, and it is our largest, darkest box that we had placed. And then the second year, all four of the boxes that we had mounted were used, which was also exciting. And then in the second year here, they kind of seem to have settled on this box C, this gold one here, which, you know, kind of is consistent with the previous year. And although they didn't really use the other boxes very much, the boxes here in green and teal, those were the boxes that we placed, so they are still using them, maybe just less so. So, you know, despite our small sample size and steady seasonal differences, we were able to come to the conclusions that the little brown myotis colonies are relatively resistant to this roost disturbance. And despite the attempted eviction, they were still willing to return to the roost, and they used the boxes that we had mounted quite frequently. The rate of our box uptake was relatively fast compared to some other studies, about 7 days after the attempted eviction, sorry. And occupancy consistently increased over time for those boxes. So it was good to see those results. You know, if a roost eviction or a roost disturbance is deemed necessary, we suggest having plenty of boxes to put up and not just one style. Likely doesn't encapsulate the entire microclimate that's going on in there. So, you know, but larger, darker boxes seem to be something that they like, likely for that solar heat capacity, or even being able to move between chambers, having that space. So we do suggest that if you're going to do that, to place plenty of different styles of boxes, and hopefully the bats have other things like large, ample forest cover, and placing boxes on buildings, we think would likely be a way to attract bats to those boxes. Yeah, so if members of the public are looking to evict bats from their homes, we suggest that they do that a little bit later in the season, just because partial fission of the colony is already occurring due to swarming. So probably have a lessened impact on the roosting behavior of those bats if you're doing it a little bit later in the season. So yeah, I'd just like to thank everybody for their time, thank ECCC for funding this work, and Dr. Karen Vanderwolf has been helping on earlier versions of this manuscript, so I want to thank her. And just appreciate that our work was done on this unceded traditional territory of the Mississauga and Anishinaabe First People. And it wouldn't have been possible to do this field work without their continued stewardship of this land. So I just wanted to acknowledge that as well. Thank you.
That was great, Sarah. Thank you very much. Does anybody have any questions? Yes, at the top.
So when you guys were setting up these different sort of bat boxes, were you looking at, I saw one that was isolated on a post and then others that were on a building. Did you notice a preference between either of those setups?
So the question was different bat boxes, any preference?
Yeah, that's a really great question. So the photo of that box on a pole was one of the existing boxes that the homeowner had mounted. And they were using that box, one bat was using that box before the eviction, but we didn't mount any boxes to any poles. As a comparison, we mounted all our mitigation boxes on buildings. And that kind of being a factor of the study itself, you know, we obviously had a much larger frequency of bats in boxes that were mounted to buildings because we only had the one on the pole to compare to. I have read some papers, though, that did do comparisons to poles and boxes on buildings, and I know it's just one of those things that's hard to tease apart. There's a lot of theories about thermal stability on poles versus on buildings, and I think there's a lot of questions to do with how that thermal stability relates to their, you know, whether they actually are preferring that box to another box. So yeah, we don't know. This one, if we had had more boxes to mount on poles, that would have been great, and then we could have really done that comparison, but that's a great question. Go ahead.
So you were talking about like roost type selection. I was wondering
Oh,
if,
yeah.
like the weather or climate changes would have any impact on that. So like if it's warmer out, they might select trees or poles, or if it's colder out, they might prefer buildings.
Great question. Yeah. So the question was whether or not the ambient temperature would affect maybe their roost selection choice versus like something that's maybe on a tree versus on a building, right? Is that right? Absolutely. Actually, there was a part of this project that we were wanting to take temperature. We did actually take temperature data inside the boxes, so we could kind of see how that was changing with the ambient temperature or what we were mounting the boxes on, buildings versus poles and things like that. And I absolutely think that there's probably a difference in choice based on the ambient temperature of the day and wanting to choose a cooler roost when it's a really hot day versus wanting to choose maybe a box in the sun on a cooler spring morning. And we did, I recognize that we did our studies on 2 different seasons, and so that box use could have absolutely changed based on season. But yes, so we had those temperature loggers in those boxes, and we wanted to look at that actually for this project. But the problem was we weren't also taking the counts of each box when it was at those temperatures, so it was really hard for us to relate what the temperature was in that box and how many bats were in each box and in each chamber. So that would be a great follow-up for this project.
If I was reading the numbers correctly, the maximum you had in that box C was 10. How did that compare with the maximum that were in that cabin?
Oh, in the initial roost. So that's a great question. We did do emergence counts at the very beginning. It's just that the emergence counts were kind of varied, but we counted approximately, I think it was 18 bats that came out of the original roost before the disturbance. So, if we estimate that colony at around 20 bats or so, 10 bats in that box was actually a pretty good number to see, especially when you see the first year of data, it's really just like 1 or 2 bats that were using the boxes at first. So to see kind of consistently 10 or 6 or around that area in that specific box kind of made us think like there's something going on with this one specifically.
Time for one more question.
Yeah, go ahead.
Do you know, for the bats that sort of left the building area and parked themselves at other locations, I think some of them were buildings, maybe some of them were bat houses. Do you know if any of those locations had pre-existing colonies of, little browns or big browns or whatever?
Yeah, we don't know necessarily, especially, there was actually, oh, my slides are gone. So the second year we, no, it's all good, don't worry about it. Within the second year, they did that a little bit more, right? They kind of just left the roost and parked themselves in these various locations. And when we were to track them to those locations, we found a really old box that had quite a lot of bats in there. And so it would have been really difficult to tell if those were all the same bats from our colony or a new colony. So it is possible that they had other colonies for sure, especially because, I don't remember what I was going to say, but yeah, I think that that place was a little bit farther away, so it's very possible that some of the bats in that box were from another colony. It's very possible. We also did catch some big brown bats in the first year, so we do know there's lots of bats in the area, so yeah, very possible. Thank you.
That was great. Thanks, Sarah. So just an announcement for our upcoming speakers, some tech issues on the fly here. If you are interested in using presenter view, we can accommodate that, but it has to be done with your own laptop. So if you've got your own laptop, we can accommodate that for your upcoming presentation. So thanks again, Sarah. Our next speaker is Heather Fotherby. Heather is a member of the Ontario Bat Network Organizing Committee, and she has been a biologist with Natural Resources Solutions Incorporated for more than 10 years now. And her presentation this morning is going to be on Southern Ontario bat capture rates and Northern Myotis roost tree selection. Welcome.
Hi, everyone. Can you hear me all right? Yeah. I wanted to talk to you today about some of our preliminary results from the first year of a 2-year study focused on trying to learn more about the distribution and characteristics of maternity habitats of our tree roosting species at risk bats in Southern Ontario. As you might have guessed, our target species are Northern Myotis, tricolored bat, and little brown Myotis. So just to take a quick step back, what do we know about maternity habitat in Southern Ontario? And I'm talking about maternity habitats in natural habitats, not in anthropogenic structures. Well, as most of you know, we know very little about where these maternity habitats occur in Southern Ontario for these 3 species. For example, this is a map from the Provincial Recovery Strategy showing the occurrence of Northern Myotis across the province. We know of 1 maternity site for this species that occurs in natural habitats. Tricolored bat, we don't know any maternity sites in the province. And last but not least, for little brown Myotis, we know quite a few associated with buildings, but we only know of 1 maternity site in a natural habitat. Or at least I'm only aware of 1. So why are there so few maternity sites known in natural habitats for these species? Well, it all comes down to how hard they are to study or how challenging they are. It can be difficult to access natural areas, and the effort required to identify these habitat types can add up, can be quite costly. Historically, we've focused on easy-to-access sites, such as buildings, and sites where there are high concentrations of individuals, such as overwintering sites in mines or caves. We have acoustic surveys now, which are becoming more and more available and easier to conduct, but we really only have data from these from the last several years. And acoustic surveys can be great at identifying candidate habitats, but we really need to conduct capture to confirm bat species ID and telemetry to find out exactly where they're roosting and if they're using the habitat. Currently in Ontario, neither telemetry nor capture is required as part of impact analyses for proposed developments. This is potentially a lost opportunity for us to learn more about these habitats. So what have we been up to for the last year, and how are we trying to address this general lack of knowledge surrounding maternity habitats in natural habitats? Well, in collaboration with Landcare Niagara, last year we selected 4 primary sites to conduct mist-net captures at. Each of these sites were forested habitats, and illustrated here actually with the yellow stars. We conducted 5 to 7 nights of capture surveys at each of these primary sites during the peak maternity period last year. And we also managed to squeeze in a couple extra nights of surveys at two additional sites. This table here just provides a little bit more detail with regards to our survey effort at each of these sites. Our primary sites were located in Haldimand, Hamilton, Norfolk County site number 1, and Waterloo Region site number 1. So what did we find? We captured 6 species across all of our sites, the majority of which were big brown bat, as you can see in the pie chart on the right. We also captured small numbers of eastern red and silver-haired bat, little brown, eastern small-footed myotis, and northern myotis. The sites with the highest number of captures were our Hamilton and Norfolk County site number 1 primary sites. When we look at the capture rates at each of our primary sites, you'll notice that they are relatively small. I don't know if you can see the scale on the bottom of that, but it ranges from 0 to 0.6 captures per net hour. We were fortunate to receive some data from a study that was completed in the 80s in order to be able to compare our capture rates to pre-white nose syndrome capture rates. The study conducted capture surveys at or within the same forested habitats as the capture surveys that we conducted at our Norfolk and Haldeman sites. So looking at the data, the 1985 study is across the top. You'll note that their capture rates are a little higher than what we observed last year. And what sticks out to me is that purple bar and that orange bar, which are the capture rates for little brown myotis and northern myotis. And you also note at the end there, the navy blue, which is tricolored bat. So how does this translate to survey effort that might be required to capture and study our species at risk bats currently, at least at our sites? In 1985, they would have thrown up 4 single high nets, and within less than an hour, they were capturing little brown myotis. And just over an hour, they would have been capturing northern myotis. When you look at our data from last year, it took us 11 nights of surveys before we captured our first little brown, and 21 nights before we captured a northern myotis. But were we ever excited to capture that northern myotis? We captured her at our Hamilton primary site. And the icing on the cake was that she was a pregnant female. Meaning, I'll get into that in a minute. We attached a transmitter to her, released her after tagging her, and tracked her during the daytime. Her tag retention time was 5 days. And we tracked her for 4 of those days to 4 separate roosts. Canada Day did get in there. And we were excited to identify the second maternity habitat in Ontario in a natural setting that we're aware of. So some of the roosts that we tracked her to were pretty interesting. The first one we tracked her to was a sugar maple with a diameter at breast height of 35 centimeters. The roost height is circled in orange there and was 1.6 meters above the ground level. The second roost that we tracked her to was a slightly smaller tree in American Beach with a diameter at breast height of 16 centimeters. The roost height was 1.5 meters above ground level. And this one, the third roost that we tracked her to was even smaller at 6 centimeters DBH, and she was only roosting 0.46 meters above ground level. The last one that we tracked her to was, again, a much larger snag, a white ash, with a 46 centimeter diameter at breast height. And we couldn't see any obvious cavity or crevice on this tree, but there was a lot of sloughing bark. So we're assuming that she was roosting under some of that loose bark at the top there. We estimated the height of the roost with the use of a clinometer to be about 13.5 meters high. Lots of sun exposure up there. So in summary, pre-white nose syndrome capture surveys were very effective at capturing our species at risk bats. And we can't protect habitat if we don't know where it is or what it looks like. And I think the first step would be to find where they're roosting in southern Ontario. So we have one more year of funding, and we have a lot of work cut out for us, or we have our work cut out for us this year. I'd just like to say thanks to everyone that has supported this project so far. The project was funded by the Provincial Species at Risk Stewardship Program, and we've been working really close with Landcare Niagara to complete all of our field work. Oh, and a special thanks to our very dedicated co-op student who isn't here today, but we wouldn't have been able to do this without her. Thanks.
Most of the short groups, and also what, like, was there more than one bat, or was there one bat roosting in that?
So the first question was, can you remind me what the height was from the shortest height from the ground? And it was, I think, around 0.5, yeah, 0.46 centimeters above ground level. Oh, sorry, meters. Yeah, that would be pretty, meters. And the second question was whether or not we knew there was more than one bat roosting in some of these roost sites. Unfortunately, we didn't conduct an emergence survey until, what was it, like a week after? About a week after she dropped her tag, so she was no longer roosting. Well, we don't know if she was roosting in any of these trees, and everyone that helped us conduct the emergence surveys, we did them all on one night at all of the roost trees we identified, and no one had any bats emerging. It was while we thought it still had a tag, but we weren't able to find it that day. So it was probably the first day it dropped the tag. Okay, that's right. Okay, so we weren't sure if she still had her tag or not. So we did conduct it pretty close to tagging the bat. Sure.
I'm curious how you determine the location of your netting sites. Were they already, did you acoustics first to find out if there were bats, certain species in the area, or was just looking at appropriate habitat to set up nets?
So the question was, how did we determine where to set up our nets? The original plan was that we would conduct acoustic surveys first. But our funding came in a little late, so we just jumped right into netting in our first year. And we selected our sites based on, there were a bunch of factors, but we tried to select ponds or wetlands that we can net over where they knew they would come to drink. We netted along trails in forested habitat. We also netted in the exact at one spot in the exact location where they netted during the 1985 study. One of our volunteers had helped with those surveys. What else did we use?
How we selected sites, or where we put them?
How you selected the site?
Uh,
So it sounds like you're basing on habitat in previous studies.
yes. Just to repeat that, we based our selection of sites on habitat and previous studies. Yep.
Did you do swabs on the northern Milos for white nose syndrome? Did you know if it had any signs of it?
We didn't do swabs, but we looked for evidence. And I can't remember if the northern had evidence of white nose. No, it didn't have any evidence of white nose, but we didn't conduct a swab.
Honestly, why you would expect, why you would do swabs because you would expect
Yeah, I'll let you explain that.
We don't really do swabs in the summer because we wouldn't really expect to detect the fungus very much because it doesn't really grow in temperatures over like 20 degrees Celsius. So yeah, we don't put effort into doing that and running those tests because I think Liam's done a lot of that work. They usually don't really have much fungal load in the summer, right? It usually clears up and then they get reinfected in the winter.
Thanks, Christy. Is there still time? Okay. Sure.
Just a quick question. I'm sorry if you have to speculate. But so some of the literature on like roost locations for certain kind of Myotis peg them on kind of like higher features, further up trees, maybe larger diameter trees. Do you have any sense for is this just more of like an unknown kind of feature, or whether this was, I guess, what I'll call like contingency roosting, like the area that you were looking at didn't have the big trees with the high up features that would be ideal, and so they were kind of finding what was suitable. I guess. So sorry if you have to speculate on that, but I don't know how much that was included.
So the question was, maybe if I reword it a bit and you can correct me, was there larger diameter trees in the forested habitat where we were tracking the northern that were available for roosting, but we were finding her using these smaller diameter trees. And this was a mature forest. So there were larger diameter trees available. Yeah. Well, if you didn't hear that, Christy said that it was an old growth forest.
We have time for one more question.
Sorry, I need to go to you because you keep putting your hand up and I.
I was just wondering, of the 4 roosts that you found, how far apart were they? Like, how far was she moving between them? And then also, sorry if I missed this, but were some of those roosts used for multiple nights?
We don't know if they were used for multiple nights. We missed one day of tracking during those 5 days that she retained her tag for, and every day that we tracked her, she moved to a different roost. There's the distance between her capture site and one of the roost sites that we tracked her to was 380 meters. I can't remember the distance between the other ones offhand.
Less than 380 meters?
Yes. Oh, I guess that was one more question. Okay, thanks.
Thank you, Heather. So our next speaker is Lauren Moretto. Lauren did her Master of Science at Carleton University, and for the last 3 years has been working at Credit Valley Conservation. Unfortunately, Lauren has been unable to join us in person, but she kindly pre-recorded a presentation, and so we will give her presentation virtually. Her presentation is a book to which is about to be published, to which she is both an editor and an author, a contributing author, and the book is Introducing Urban Bats, Biology, Ecology, and Human Dimensions. Editor and an author, a contributing author, and the book is Introducing Urban Bats,
why are we hearing that?
Biology, Ecology, and Human Dimensions.
Sorry, we've got a bit of feedback here.
Okay.
So I'd like to reflect a bit on how this started for me. Back in third year undergrad at the University of Toronto, St. George campus, I was, as many undergrads are doing, trying to figure out where I wanted to go and what I wanted to be. And our mammals class had Brock Fenton as a guest speaker one day, and he gave an excellent presentation, and I was really, really inspired and excited to maybe dabble in, looking at bats a little bit. So I became involved with a couple of projects, one out of High Park, which was looking at bat activity in the park through recordings, and one at the Royal Ontario Museum. U of T had an affiliation with the Royal Ontario Museum, and so quite often the students could work with curators at the museum as well. So I was fortunate enough to work with Burton Lim on a little project about fossilized bat bones. It was my first published paper. And at that point, I was hooked. And so in fourth year undergrad, I put together a little thesis project, a review paper, and over time that manifested into an actual published review paper titled "What Factors Limit Bat Abundance and Diversity in North American Urban Environments." I was really, really excited about this paper, but we had some additional content that was kind of sitting on the side as well. Brock Fenton had proposed that it would be really, really interesting to look at essentially what makes a good urban bat. But at the time, the research just wasn't there. We were just starting to see a rise in urban bat research. So, apologies here, the text is cut off by my camera, but if we fast forward 4 years, you'll find me at the NASBAR conference in Kalamazoo, and as with any of these North American Society for Bat Research conferences, I was very inspired. There were outstanding presentations, and so that's really got me thinking again. Maybe it was time to go to that review article. Maybe it was time to kick off the dust and start writing it again. I thought at the time, you know, the research had developed. There were more papers that had come out about urban bats. And so I went back to Brock about this idea and I said, well, what do you think about a review article? And he said, well, maybe we could turn this into a book. And so that really had me thinking, well, great, okay, this is a big undertaking, but this would be really cool. Let's look at something that makes a good urban bat, and let's see what research is out there, and maybe we could tie this all into a book to tell a story, a global story essentially, which we'll get into in just a little bit. So, why urban bats? Well, I mean, apart from a personal interest in urban wildlife and urban ecology, there are some big, notable, I guess, points here about urban environments. These are environments that are highly anthropogenic, you know, tailored to the needs of humans. But wildlife has learned to adapt to these environments, and I think that's a really, really outstanding ability. So by actually 2050, it's predicted that 70% of the human population will live in cities. And this is going to accompany a 40% increase in the amount of land covered by urban development. But as I've mentioned, this space is also home to wildlife, including bats. And bats are species that have actually been found out of different mammals to adapt quite well to urban environments. But, like other species, bats must contend with the pressures of profound and irreversible land cover change and overcome some very unique challenges of urban environments. Again, they're very tailored to human living. So, some bats are actually synanthropes or synanthropic. And in other words, although most species of bats, yes, are negatively impacted by urbanization in some way, many appear not only to succeed, but thrive in this human environment. And so this observation has really sparked some interesting questions about bats in relation to urbanization. So this had us thinking, well, which traits and behaviors equip bats for urban success? And what features of urban areas really affect the likelihood that bats will successfully persist or even colonize new areas? And how does the success or the fact that bats reside in urban environments affect cohabiting humans, and what's that relationship between bats and humans? So we'll get back to that in a second, but this is where we really pulled together an awesome team. And although I wanted to write this little review article, it's at the beginning of all of this, it's really this outstanding team that manifested this little idea into an amazing book. And I'm forever grateful to not only the excellent group of editors, but the over 40 international authors who have dedicated their time, volunteered their time to compose this, the content of this book. So our co-editing team was made up of 6 co-editors, Christina Davey and Brock Fenton being our locals here. But yes, we also had over 40 international authors who contributed chapters, and we did this project and published through Springer. And so we had this excellent team bringing together their expertise and knowledge from a diverse array of subject matter to really pull together a mosaic of urban bat research. And so this is a really unique approach. Instead of trying to detail everything we knew about urban bats, we decided to rather pull together different snapshots of urban bat research that would provide insight into different, again, fields of urban bat study. So we set out to build the foundation of knowledge about bats in cities and adjacent areas, but also in this way, in identifying gaps in the research, inspire future research, and promote conservation of urban bats and get people thinking about urban bats. So this book, we really intended it for it to be a resource for environmental managers and an academic audience. And the unique feature of this book is that it brings together research from all around the world, which has never been done before, about exploring the interactions between bats and urban environments. And so this book is broken up into 3 main sections. We wanted one section to focus in on different aspects about the biology. So we have chapters that look into morphological, physiological, behavioral, and genetic adaptations of urban bats. Everything from, again, parasites to genetic bottlenecks is covered in this section of the book. And then the second section, we tried to look at their ecology. So bats using artificial roosts, and artificial roosts like bat houses and bat condos as maybe being used to support urban bat populations, and the success of that as well. We dived rather into green spaces and blue spaces as urban bat habitats, but also looking at an emerging field of research, aeroconservation, and so dabbling in, aerial habitats for bats in urban environments as well, and trying to inspire some research, as this is a very new emerging field. And so the third section of the book then focuses on bats and humans interacting in urban environments. So we're looking at human perceptions, public health, and ecosystem services of bats. And then the final chapter is more of a big picture chapter that ties together all this content, summarizes this content, and really looks at defining urban environments for future research, but also comparing bats to other mammals in their ability to adapt to urban environments. Again, that overarching summary chapter which kind of closes the book. So again, we've created here a mosaic of urban bat research. This book really stands to be, we hope, a foundational research for reference about some things we do know about urban bats and things we don't know about urban bats. So we're looking at, various, for example, morphological, physiological, and behavioral trends, parasites in bats, but also public health in bats. This book came out in a unique time when we were going through the COVID pandemic, and so we were able to tie some of that information into the book as well. We hope that this book can help direct conservation and management actions. So looking at green and blue spaces or maintaining genetic diversity, outreach and engagement of the public, the use of bat roost structures and their success in certain applications. And looking to, again, as I've alluded to, inspire future research. Ecosystem services about urban bats. Maybe we could use some more research there, or management plans for aerial habitats, given that aerial conservation is a very new field of study. And planning of engagement of the public or citizen science projects to get some more research, given that, again, bats are occupying a highly human area in the world as well, being in cities. So I just wanted to tie this into a kind of a local application, a potential application for this book. I work at Credit Valley Conservation, and our jurisdiction is the Credit River watershed. This extends all the way from basically the shores of Mississauga all the way up to Orangeville. And it's a big, expansive area. And so we were talking about maybe how this book can have, tie into informing some local work, research, and management of bats. So in this watershed, we have 8 insectivorous bat species. They have different life histories, ranging from generalist to specialist, species that hibernate to those that migrate. And 4 of these are species at risk. However, some of these species are synanthropic. So this is wildlife, given that Mississauga, Brampton, and now Caledon, and partially Orangeville, Georgetown, we have some urbanizing and highly urban areas. And so synanthropes, as I've mentioned earlier, are wildlife that lives in close association with people and benefits from its surroundings and activities. But in the Credit River watershed and at Credit Valley Conservation, due to research or resource limitations rather, they've conducted a lot of roadside surveys in rural areas, but they'd like to learn a little more about the urban bats, given that a third of the watershed is covered by urban land cover. So I've talked to Dawn Renfrew. She works with the Natural Heritage Program at CVC, and she's mentioned that, they're aware that a lot of bats exist in urban centers or green spaces in these urban areas like Rattray Marsh or Meadowvale Conservation Area, but they don't know how they're distributed in urban areas. And so it's a big question mark for Credit Valley Conservation at this time in terms of what the bats are doing. And she mentioned that, it would be helpful to understand what is already known about urban bats, so they can, this book can potentially inform, designing urban bat inventories. It would also be helpful to know if urban bats kind of act differently or behave differently or have different rules or different needs for management, because there are so many different unique challenges to, planning conservation areas and various applications that occur within urban settlements that may not occur within those rural areas. So this book can start to have people thinking about, what they may need to look at within urban areas to inform future work. So I was really pleased to hear that within my own workplace, but generally we hope that this work shines a light, or maybe removes that light, and keeps that dark space for urban bats, but shines a light rather on research and developing future knowledge and understanding for urban bat protection, conservation, and management. But not literally. Thank you, everyone. I'm happy to take questions, although I can't be at the conference today. You're very welcome to send me questions via email. Thank you. Hello, everyone. I'm sorry I couldn't be with all of you.
That was weird.
We can give you Lauren's email.
So yeah, I did wanted to encourage your applause for Lauren's presentation. Obviously, she's not here, but we hope that she'll view a YouTube recording of today's events, and obviously she would appreciate your appreciation of the time she took to put into preparing the presentation. So another round of applause for Lauren. So, and with that, that brings to a close the second session of today. We are exactly right on time. So with that, I will turn it over to Brad, who will announce our plans for lunch.
Super, thanks, Chris. So we have 2 tours starting at 12 o'clock and 2 tours starting at 1 o'clock. If you have a question as to whether or not you're on the list for a particular tour, please see me. I don't really want to go through all of the names and read them all out, but I have the list right here. So, Paul, where are we meeting? Are we meeting up in the lobby? Perfect. We're meeting in the lobby for each of the meetings. We have an hour and a half for lunch. As we've noted, there's a lot of places that we have to go to walk if we want to go out in the weather today. There's lots of places to eat outside. We don't have lunch here for you today, unfortunately, but that's kind of where we're sitting. So hopefully everybody will migrate up to the room upstairs where we have refreshments if you're not going out for food. I think that there also may be some opportunity for DoorDash or one of those things if you don't want to go out in the weather. So let's not all kill DoorDash and have 15 people come in here, but it's worth a try. So yeah, if you're on a tour or you don't know if you're on a tour, see me or meet in the lobby, and we'll be back at 1:30 for another presentation. Poster presenters, if you could please be with your posters between 1 and 1:30, that'll give people an opportunity to ask questions and review those. Thank you. page. We started our YouTube page, and
Okay, and I know some people really hate Facebook and just like do not have an account and will not use it. And that is totally okay because we have a Google group mailing list. There was a slide, the writing was very small for how to join, but you can email ontariobatnetwork@gmail.com and we can provide the instructions for how to join the Google group if you're not in it already. But yeah, it's great for folks to just email out questions or whatever else, and you have access to the whole network of folks to potentially answer your questions. So yeah, there's also that option as well. We're getting into our third session now, where we'll be hearing a little bit more about different types of survey tools and stewardship activities. So first up, we have Nina Garrett, who is presenting about her use of airborne eDNA to survey bat roosts.
Okay, can everyone hear me? Okay, good. Okay, so I am a student that is a master's student working out of Elizabeth Clare's lab at York University, and my master's research looks at using a novel method of airborne eDNA to, in this case, survey bat roosts. So eDNA, for those of you who don't know, stands for environmental DNA, and it's fragments of DNA that we get from the environment that isn't directly taken from an organism. So this can be bits of hair, skin cells, saliva, or even extracellular strands of DNA. We've detected it in the soil, in water, and even some unconventional methods like honey or in the guts of vertebrates that feed on things like blood, so mosquitoes. Airborne eDNA, however, is relatively new. So up until now, at least for surveying the terrestrial environment, has been primarily theoretical. Most practical work has looked at pathogen and bacterial communities, with a little bit looking at plants and fungi communities, using these dust traps here. And the way these work is they passively sample the wind, essentially, and settle particulate matter out of the air, and then you take that particulate matter and extract eDNA from it as you would a soil sample. In 2021, my supervisor published a proof of concept paper that was performed in a very controlled environment that showed that we could in fact get airborne eDNA of terrestrial vertebrates out of the air and use it to identify what they were. Since then, there's been a handful of studies that have expanded on that and looked at less controlled environments. And again, we were able to find that we could still detect those vertebrates with pretty high accuracy. So what I wanted to do for my research was use that active sampling method to see if we could use airborne eDNA to detect bat biodiversity. So I used these three samplers here. For this experiment that I'm talking about today, it's only the large ones. But we had three different prototypes that we took down to our field site, and there's an example of them being deployed behind a bat line in our field lab. So I wanted to specifically look at roost surveys. This is a potentially non-invasive, semi-remote way of surveying roosts, or at least that's what we thought it would be. The previous studies that had looked at this work suggested that cavities, tree cavities, caves, burrows would be an ideal use of this method. So we wanted to test that out under truly natural conditions to see if we could detect wild bat populations. And we deployed our samplers in 4 different roost type categories in the Archaeological Laminae Reserve, the Kakabish Mayan ruins, and the Indian Creek area of the Orange Walk district in Belize. So the first roost type category was the natural caves. An example here, this is called the Schoolhouse Cave, and I'll be coming back to talk about this a little bit later. The second kind of group was man-made tunnels made into Mayan ruins by looters and archaeologists. The third was other man-made structures, and this consisted of an old cistern and then an attic. And finally, of course, tree roosts. So here's some of our tree roosts and then our other natural cave. For some of the all the tree roosts, we couldn't actually enter the tree roosts, either because the entrances were too high or too small. And then for this cave here and then one of our tunnels, it was actually too dangerous to go inside. So this cave has a very steep vertical drop almost immediately, so we couldn't physically enter those roosts. And in those cases, we either draped them inside or just put them at the entrance. All other roosts, though, we put them quite far into the roosts where the bats were. We sampled most of them for 24 hours, with the exception of a few. So the tree roosts were in the archaeological reserve, and that's open to the public. So we were asked to only survey during closed hours, so that the public didn't see us going in there and effectively vacuuming the sky. And they also, because they couldn't go inside the roost, they weren't protected from the rain. So we only ran those for about 6 hours because we didn't want our batteries and our electronics to get destroyed if we couldn't get to them in time. It worked remarkably well. So here's a list of our roosts and the bat species we detected, and then the other vertebrates. So we detected 11 bat species, 10 of which had either been confirmed in those roosts or the area around those roosts that trip or on previous field trips. We detected several non-bat vertebrates and a couple amphibians, non-vertebrate mammals and then a couple amphibians. And this was really encouraging. So what this means, or we think it means, it's still kind of early days, is that we can semi-remotely and pretty non-invasively survey not just regular roosts, but hard-to-reach roosts with high accuracy. And that can be game-changing for two reasons. So the first is you don't need physical access to the organisms. So this cuts down roost disturbance because you're not having to handle the bat. And that Hello? Oh, let's down on this side now. Okay. Where was I? Oh, yes. So it can reduce disease transfer, either between humans and bats and humans, or between bats themselves, because you don't actually have to handle the bats to figure out what species are in there. And that can be really important for things like white nose syndrome, where you don't want to necessarily be transferring one disease from one bat to another. It also could potentially reduce the time and manpower needed to survey multiple roosts. So you can set up your samplers in one roost, leave see here, you've got frequency and then amplitude. And you see two little spikes in frequency and amplitude, and that's the big-eared climbing rat. But what you don't see is an elevated background frequency or amplitude. So what we think that means is our samplers are relatively quiet and they don't emit high-frequency noises, which when you're working with a species that is sensitive to things like that, it makes a huge difference if you want that method to be non-invasive. With all those great things, we still have a lot of questions to answer. So we don't know how many samplers we actually need to survey a given airspace to totally get the diversity in it. We don't know how long we need to sample for. We don't know how far it travels. So in aquatic systems, we know that eDNA drifts, and we suspect that it also drifts on the air. And that's important if you're looking at roosts that are close to each other. You don't want to get instances where eDNA from one roost is drifting into your second roost and confusing who's where. So we don't actually know how far it travels. We think it settles out relatively quickly, but again, something we need to know. We don't know if the size of the roost matters. It likely does, but in an enclosed space, we don't really know. And then, as I mentioned before, we don't really know when we need to sample. The goal, really, and the true test of this, will be to develop a comprehensive protocol that would allow for semi-automated sampling and monitoring for the terrestrial ecosystem, similar to what we see in aquatic eDNA, where for aquatic surveys, eDNA is pretty commercially and by the government as well employed to do biomonitoring and biosurveying. And that's something that we would like to replicate with the air, as well as expanding it so that we can ask more ecologically complex questions rather than just, is this species here or not? So that might be things like occupancy modeling. But we've had a lot of interest in this, and so we're really excited to see where it goes. I'd like to give a quick special thanks to all the co-authors who helped me with this paper that will be published soon for York University and the NSERC for funding, and of course all the people who were on the field trip that helped with bat captures, and the Lamanai Field Research Center for all of their help and support.
Do I have time for questions? What an awkward microphone to pass back and forth. We do have time for questions, if there are any. Pardon? Is it working now?
We think so.
Oh, excellent. Fail.
Go ahead.
This is all news to me, so forgive me if this is a silly question, but, so I'll say this, cool talk, and very interesting. What is the, chance of a false positive? Is there a chance of a false positive?
Yeah.
Specifically thinking that you have two different species, but you actually only have one, for example.
Okay, so the question was, what are the chances of a false positive, and the instances of where you think you have two species when you actually have one. So there are false positives are always a concern when working with eDNA, but we have sort of built-in checks and balances along the way, PCR controls, extraction controls, things like that, that then help us when we get to the bioinformatics stage to filter things out. So we had the added benefit in this field site of having a very specific and well-documented historical set of data for what was in the area, which of course isn't going to always be the case if you wanted to deploy this kind of fresh. So then you're looking at things like, if you look at your PCR positive control, if it's contaminated with something or your negative control, sorry, if it's contaminated with something, which when you're working with vertebrates is usually you look at the read count, which is the amount of DNA in it, and you typically get rid of any hit or detection that has a read count lower than that. You do have to be careful with that because sometimes, again, you can get rid of true positives that way. That's like the very, very conservative way of doing it. There's other ways that are a little bit more forgiving. But you can also look at range maps and stuff. So in one of our other experiments that we did in that field lab, we were getting detections of bats from Africa and Europe and stuff, and we're like, that's what? Turns out people had worked with those species before coming, and we think what was happening is we were getting secondary transfer on their gear. So it is very sensitive. So yeah, those bioinformatic checks are really important, and then replicates. So the white-winged vampire bat, we're pretty sure it's a true positive because had very high read counts, and we sampled that roost 3 different times, and it was the main hit every single time. Does that answer your question? Okay.
So I guess I think eDNA is cool, but my I guess question, and anytime I hear an eDNA talk, is like it's basically presence absence, right? Which is important.
Yeah.
But if you want to know like how many white-winged vampires are there, that's like a challenge. And I know there are ways to get around it. So I'm like with regular eDNA, not airborne. So I'm curious, like, if you have any thoughts on that?
Yeah, that's. Oh yeah, the question is, so eDNA, it's often presence-absent data. Can you get the number of individuals, correct? Yeah. That's a really big debated question in the eDNA community, and everybody really wants the amount of DNA to mean something. And there is evidence that it can, but so in that the other study, we did look at that. So for us, there was a positive correlation between the number of bats in the room and the number of detections we got, but there were 3 outliers, ones with really high read counts compared to what they should have been with their abundance, and then one with really low. Those were species, the ones with really high were species that were very hard to tell apart. So my supervisor was basically taking them out right next to our samplers and looking really closely at their teeth and handling them a lot to figure out which was which. So they probably shed more DNA. Whereas the one that was really low was the common vampire bat, and you can just poke the bag and it hisses at you. You don't even need to take it out of the bag to know that it's a vampire bat. So there is some evidence of it, but I think at least for airborne eDNA, it's still too early to tell if we'd actually be able to do that. So the question was, do we have a sense of how long the DNA signature persists? There was a study done out of Texas that used the dust collectors, and it looked at 2-week intervals. So we know that it in most cases, isn't longer than 2 weeks. And again, that classroom field lab experiment that I was talking about earlier, we noticed that it was a couple of days. So right now, again, that's something that we want to find out, do a little bit more work specifically focusing on that. But for now, it's anywhere between 2 weeks and like 3 days. We think it settles relatively quickly though. But yeah. Okay, thank you.
Thank you, Nina. Next up, we have a presentation from Derek Morningstar and Toby Thorne, right? Yeah, on to tell us about the North American Bat Monitoring Program.
Okay, thank you. And my clicker. So to answer everyone's question, by the way, it's not a good bat conference until someone dresses ridiculously, okay? Everybody wondered about the shirt. Okay, so so when we were kind of planning this conference, we wanted to have some representation or a talk about NA BAT. So I'm going to tell you what it is soon if you don't already know. And we invited the coordinators of it from the USGS to give a talk for us, and they said, we'd love to. And then they said, but we have another conference, sorry. So I kind of got nominated because I post data to it to tell you about it and to do something else here. So some of this information is mine and making things up, but I also stole a lot of their slides. So you're going to see some stuff that's information about it. So I want everyone to get their phone out right now. Everybody get your phone out. Okay, this is an interactive thing. While I'm going through this presentation, I want all of you to fill out that survey. Okay, so we're going to talk about what NA-BAT data is. And we all want to know from you if you have any, if you want to post it, if you have hurdles, what can we do to help? Because we want to try to get more data into it. So that QR code is going to stay up there the whole presentation. So if you were slower pulling your phone out of your pocket, get it out now. and you can still do it. Okay, so the NA Bat monitoring program is an international tool that's mostly for North America, predominantly in the US, but there's quite a bit happening in Canada now, to try and survey bats across the continent and look at a high scale what's going on. And this is kind of an example of what you can sort of get out of it. They do these modeling things. This is based on acoustics everywhere, particularly for northern myotis in this case, saying, okay, what's the probabilistic, where are you going to find them now? And this is, I think it was 2019 this data was from. If it was 10 years or 15 years prior, you'd probably find them everywhere. But what you can see here is, so this blue line is like the distribution of northern myotis, and you can see there's some huge white gaps. So granted, we might have those lines wrong on the distribution, that we certainly aren't confident on where it actually goes to, but there's a huge gap of where we just don't have any data for a lot of Canada because people aren't really posting it. But that data exists. People are collecting data, so we can do it. So the NABAT monitoring program is, as I was mentioning, so this is kind of their mission and their goals, is to come up with standardized protocols on how to collect acoustic data, but also capture data and colony count data, and use a general sampling design to do that, and then integrate all that data together to come up with big high-level models like I showed you. So they have lots of different methods, papers. People have been using that data. Some people that don't even collect the data of their own, it's public access data, you can go and get it. So this is kind of what they're trying to do to look at changes over time of bat populations. And so this is kind of another example of how many people have been contributing to it. So in 2019, there was a little over 100 projects on there. Get to 2022, we're like 700 projects, and even since then, there's been quite a few more added. So there's a lot of projects on here, right? And like I said, it's public access data, so anyone can go on there and request some data and do some interesting stuff. So you can see the data is definitely growing. So this is kind of what they have as a grid design. So probably the first people they thought they were reaching out to was like state managers and provincial-wide, like government managers that were setting up a program to sample for bats in a grid pattern across, at first the US, now in Canada too. And so they devised this grid sampling design. Well, they didn't come up with it, but they're using it. It came with somewhere else. So they're trying to cover all the areas. And in a lot of places you have, particularly in the US, there's state biologists that are collecting this information. In Ontario, there's a couple people that have been doing a bit of it, but not as much. But then they said, well, why would we stop there? So they opened it up to anyone doing any project on bats anywhere. There's a way for you to upload that data that can contribute to it. So it's kind of like if you think of eBird or iNaturalist, anybody can go and add stuff to it. There is a process. You have to register and do it, but you can. So, of course, now we got to look at Ontario. So in Ontario, as you can see, there's not a lot going on. So each of these black squares is one of the grid cells where there's been some data contributed. And it's 24 projects from 5 organizations. 4 of them are my clients. So most of this I've put on. I'd like to see more people putting data on there. Toby has got a whole bunch of data that he's putting on too now. So we need to grow this as a community. So I'm sure should have 1,000 points here if everybody put their data in. That's what this survey is all about, to find out. So I'm going to kind of whip through some of these method stuff, but you can add stationary point data. So for those that don't know, that's when you set a bat detector out there and you leave it for a long time. Mobile transect, that's active monitoring data. That's when you have a detector on the roof of your car or you walk around with it. But there is also the option of adding colony count data and maturity count data. I think most people do acoustics, but you can also put capture and count data. So we're focused on the stationary. So some advice about getting some information on there. So if you have acoustic data in particular, you really should plan ahead. So you can add it after. I'm going to say that first, and then I'm going to say you should think about it first. Because there's a lot of little tricks that if you capture your data the right way, it makes it a lot easier later. So setting up a bat detector, I don't really want to get too much into the details, but you want to try to avoid cluttered spaces. Never stick it in the middle of the forest, right? Stick it on edges and open areas. That's what this next slide about. There was a question earlier about the detection range of a microphone. Very best case scenario, you might get 50 meters around the microphone. That's for a perfectly omnidirectional microphone, which most aren't. But there's some information that they provide in their protocols about good ways to set up bat detectors, like on the edge of a forest and parallel to it, but a few meters away. How you would set it up on a roost or near a stream or a pond and stuff like that. So if you're interested in methods on how to set up acoustics, you can look at the protocols that NABAT has. And so there is a criteria for the data to set to be able to contribute to it. So they want you to take all kinds of information about what kind of detector you used, what your settings were, and it's a minimum of 4 consecutive nights in order to post passive data. So if you've only collected for a night or two, you won't be able to post it, and if you did different nights, it won't work. So you could have the whole season every other night, and I had a client who did that. And I'm like, well, sorry, we can't take it. Anyway, so 4 consecutive nights is the minimum. But then, I have some that are 150 nights long. There's no maximum. You can keep posting. So it's really important to take good data where you set up your equipment, and I'm not going to go through this, but you should have a really good data sheet that works as a checklist, and make sure you do everything the same way every time, and you can document the information, because they're going to be asking for that metadata, which is how you set it up, where you set it up, the equipment you used, all these things. It also helps to troubleshoot if you run into trouble. And I put this a couple times. When you're dealing with metadata and putting it into here, the comma is your enemy because they use comma delimited spreadsheets. So we enter it into a regular Excel spreadsheet and it all seems fine, and you put commas in your description of the habitat, and then it splits it out to 1,000 different columns, and you have to manually don't use a comma, just don't. So there's information that they want, as I was saying, minimum fields, there's required information. So remember, when somebody else goes to look at this and they're looking at 1,000 stations, they want to know a little bit about those different stations, right? If you were thinking and looking at it, how do you standardize what you're taking? So they want to know when and where you took it, what equipment you used, and there's some optional fields of, what was the orientation. To me, I wouldn't want these optional, I would want them to be required, but they say they're optional, about more of the context of where you put it. But I would say the more information you can get, the better. It helps when someone else looks at that data. So when you first come back with all your acoustic data, you've got to attribute your data. There's tools to do this, depending which software you're using. This is with the Sonobat platform. There's other ways to attribute data. The comma should never, ever be put in one of these because it really messes things up. But the other thing I was going to point out is that it can be kind of frustrating. A lot of these things, like habitat type, I think there's 5 options. So we put these in lots of different habitats, and you have to pick one of those 5 options. So be prepared that if you have a paragraph long describing your habitat, you get 2 words here. So there's some strict criteria that you're going to have to follow eventually. And just to remind you, the comma is your enemy. And then you can analyze your acoustics. Okay, I'm going to have to whip through here. I'm not going to get it all into how to analyze. That's a tricolored bat. It's a nice little bat. You export your data, and you have to export it in their format, but they have forms, so you can do that. Again, there's different software to do that. And then you upload your data to the website. And when you upload the data, you first upload the bulk data. So that's CSV files that talk about the files you have, but not the actual WAV files. And then you upload your WAV files. That can be frustrating. So your metadata file, it all gets error checked automatically, so you spend a lot of time going back and taking out those commas and fixing all your columns and stuff like that. But then when you upload the WAV files, it can take a very long time if you have a lot of data. So the wordy slide here, there's a few different ways to do this. If you have small projects, and I just kind of threw 100 gigabytes as a bit of an example, or 100 nights or less or something like that, it's pretty easy to upload all that stuff. When you get really big data sets, like some of mine, I have several hundred nights of data and thousands upon thousands of files. That takes weeks to upload. But you can either upload it all, and then that data, by the way, your WAV files are backed up in another way. So if you have a way to back it up that way, you can just put the metadata file that talks about your files and then kind of promise to keep your data safe somewhere. And when somebody wants to look at it, they do the request through you. So then you don't have to post it, but you just have to keep a copy of that data. And there's another option, which is called the BAT-AMP format. It's actually from a different site, the Acoustic Monitoring Protocol. I forget the right word. But anyways, that basically is just a spreadsheet that says a summary of the passes per night by species. So it's not even talking about individual files. It's an even higher level one that you can put so that your data at least shows up in those data summaries, and then somebody knows that data was taken there and they can ask you for more details on that. So I've already said kind of a lot of this advice. Plan ahead, take good field notes, stay organized with all that data. The comma is your enemy. Don't forget to vet all your acoustic data. You should probably vet it before it goes onto this. It can take a long for formatting, but it's possible to do it. And it can take even longer to load those files, but once you get it all in there, there's the ability to have some really strong, powerful, high-level tools about bat populations. So I think that's the end of my time. So thank you. Do we have time for questions? I guess we have time for a question or two.
data that people collect, like batwatch.ca, is that worthwhile looking into contributing to any bat? Or
So, yeah, so there's overlapping different locations. So batwatch.ca, I believe, is more about roost counts and colony counts, which this has too. I don't know why they haven't gotten together, but I don't know if they share the data. So honestly, I don't know the answer, but it is similar data. This is a North American scale. Batwatch is more of a Canadian scale. I don't know the right answer to that, but they should probably get in the same room and figure it out. Any other questions? Yeah.
Speaking of people getting in the same room, is there much of any communication with any bat and, say, the provincial government?
Yeah, so I think, okay, sorry, yeah. So the question was whether our province is doing anything for NABAT from the ministry. And so the short answer is yes, but I think it's limited. So I know Mark Browning was doing some driving transects. I think they have some acoustic data. I haven't actually met you, but I was trying to see if there's any other government people here. So I think they've done a little bit at the provincial level. At the federal level, they've been doing data collection. I analyze the data for them, so most of that data is actually from the federal government, or a lot of that is. So there is some coming from Canadian government and provincial government, but it's nowhere near what they're doing in the States. So really, there's all kinds of other people collecting data that would be a lot more than that. So, yeah. Any other questions or one more?
Is there an equivalent that's global monitoring program?
That's a good question, and to my knowledge, no, not at this level, not that kind of data. I know there's an organization in Southeast Asia that does something like this, or they're trying to. There's other organizations, and so like there's NABAT for us, or NABAT, but NASBR is a community. There's other bat communities in other parts of the world that I know of that probably do a bit of this, but I'm not sure if they have this level of organization of data repository. Like, I mean, it's probably hundreds, just imagining all that data, hundreds and hundreds of terabytes of data that somehow they're storing. But yeah, it's huge. Do you know, Liam?
Well, it's not at this grain, but GBATnet has a project right now to
Okay.
gather global data sets.
Yeah, right, okay. Cool, yeah.
See how it comes together, but they're working.
Right, good point. Yeah, so GBATnet, look that up. That's the global version. Yeah, and I think it's not as detailed, not quite as refined, but yeah. Yeah, so you can find Google GBATnet and you can know more about the global level. I think that's all the time I have, right? I'm horrible at repeating the question. It was whether there's a global option for putting data in. Oh, we have more time. Is there any, yeah.
So you need to individually ID every wave file that you want to upload, or is there a way to say, you know, I found these 3 different bat species, here's all the data, there's the extent.
Did you fill out the survey? So that question is asked in there. So the short answer is, ideally, yes, they would like data that's already been analyzed. And vetted, but it's a public repository, so they'll take all forms of data, and they're working on ways to do analysis on there. They're working on AI programs that's supposed to be better than the auto analysis. I don't think it's really getting there, but they have a whole team of people that are trying to find ways to deal with data that no one had a chance to analyze. They're also trying to find a way to offer, maybe some people have time to do analysis for you. You can put it on, other people can do analysis. Like, they're trying to coordinate all those things at NABAT. So I didn't do a good job of talking about it, but that's another thing that they're trying to do. So it's not just finished data. You have the opportunity to at least let them know about other data.
If I had vetted, let's say 20%, would they rather I just upload 20% I vetted or 100% with the 80 that I haven't gotten to yet?
So that question was, it started with, can you upload data that hasn't been ID'd or vetted? And then the follow-up was, what if it's partly vetted or ID'd? And honestly, I don't have the right answer for that, but because I'm not the one who deals with it. But I think you can always communicate. So that the team that couldn't come today, the NABAT coordinators, are really helpful. So you can contact them, go to the website, and they will answer all those questions for you. And they really want to get your data, so they will find a way to help you. So, yeah. I think that's it.
Yeah. Okay. Great. Thanks, Derek. Okay. And next up, we have Chantel Tyne talking to us about bats in rehab.
Hello. A little bit daunting to stand in front of this group of people, to be honest. I've been a wildlife rehabilitator for 16 years, and as some of you might or might not know, you actually need 0 credentials to become a wildlife rehabilitator, which till this day still baffles me. And so, I need to have the remote here to make this work. So I want to talk about some of the challenges and obviously really cool things that we do see in rehabilitation. All these pictures are actually bats that we've had in care. So some of the facts about wildlife rehabilitation. So we see about 200 bats a year at our wildlife rehab facility. Most of those are big brown bats that for some reason or another are awake during hibernation. And still it's a wide range of reasons. We are currently very excited to work with Jeff Bowman on a project where we have orally swabbed all our bats that we have in care this winter, and he is going to be working with Sunnybrook, and they will be looking for a viral load of all these bats. So the question I always have, we don't actually know why a lot of these bats are awake. Some of them are because it's mechanical reasons, somebody's doing construction, but a lot of times we just really don't know. So I'm hoping some answers will happen with this research study Jeff is doing. We do see bat versus pet interactions, bat versus human interactions, and then we also get about 12 orphaned bats a year that we see, various species. So this is kind of what happens when we get a bat in from hibernation, or that is awake during hibernation, which is kind of now. So we do a physical exam, we swab them, we band them, and then we house them. One of the things that I didn't put in there is we do actually UV backlight all of our bat wings. I read a research study that says that you're supposed to be able to detect exposure to white nose syndrome. So hundreds and hundreds of bats in. We have not yet found one single one that's been exposed to white nose syndrome, so I think that's a good thing. So when we get bats in early, if they're big brown bats and they're 10 grams and over, and otherwise in good health, we cool them down and we put them back into hibernation. We do quarantine them for 2 weeks, and then we very gently transfer them after 2 weeks into enclosures. We have enough bats in care so we can actually house them by postal code. So we have groups from different areas, and then because maybe this is me anthropomorphizing, but I do feel that they're more comfortable when they're in the company of others. One of my observations is that even though we have these bats cooled down to 5 degrees and they are technically in hibernation, I do see the bats move and they do come down and drink water. So we do have fresh food and water available for them because I do actually see them eating and drinking, even though they're technically hibernating. If they're under that 10 gram, or if they have something wrong with them, or if there's been an exposure and we're monitoring them for OMAFRA or public health, then we keep them awake, and we do actually, much like they do here, we teach them to eat out of a dish, and so we don't have to handle them every day to feed them. So here are some of our bat pups that we have in care. I actually found the first presentation very interesting on the progression of the babies. Not last year, but the year before, to our very big surprise, we actually got into baby silver bats. That was super cool. It was, this is one of the problems as a rehabilitator, because we are not well regarded in many ways by the scientific community and never really considered. It's very difficult to figure out who you need to contact for what. Unfortunately, the MNR is not the most helpful agency when it comes to that kind of stuff. So I did actually have a conversation with Christina Davey about my silver-haired bat pups because it was kind of unusual, and she agreed with me. So at least we got that. This was a very cool thing as well. We had a mama hoary bat come in with 2 pups. We are really close to Lake Erie, as in we can throw a rock and hit the lake. And so we do actually see a fair number of migratory bats coming through. This was very cool. I actually never found out what was wrong with that bat. Particularly, she was having a lot of trouble flying, and I'm quite confident it was as a result of these pups. And they were very clingy, and it took them a long time. Actually, we had her in care until those pups were a lot more independent, and then we released the 3 of them together. So that was kind of just one of those cool things that, you know, you don't see too often. This was a very sad one. So we ended up actually from a truck that arrived here in Hamilton with a Mexican free-tailed bat that hitchhiked. And I tried my very, very best to move heaven and earth. We actually had a point of origin for this bat, and I just simply wanted to send it back. And the US government would only allow that if I got a permit to move a rabies vector species from every single state this bat had to move through. And unfortunately, this bat was from Texas. And believe me, I tried. I contacted just about everybody that I know. I talked to the curator at the Toronto Zoo because I soon realized that it was impossible to get all those permits and get them all to line up because they're only good for a certain amount of days. I tried to find a captive colony of Mexican free-tailed bats in Canada, and I figured then I'll just ship it there, and I couldn't do that either. So unfortunately, I had to end up having to euthanize this bat because I didn't know what to do with it. And again, you know, contacting all government agencies, and quite frankly, nobody was very helpful in this regard. So it was really, it was a sad, you know, I realized it's just a bat, but we all love bats over here, and it's just one of those things. I hate having to euthanize an animal that is otherwise healthy. Eastern small-footed bats. These 2 that we got in was quite a few years ago now, and we had the absolute pleasure of working with a team of the Ministry of Natural Resource and Forestry, and these bats got trackers, and they were tracked back to where they were roosting. This was actually late November, and we were able to track them. That's a site that you guys are a lot familiar with. For me, that was my first ever. As a wildlife rehabilitator, one of the fears, even I've been doing this for 16 years, I still have is that I accidentally misidentify a species. Certain species of animals, there are certain species of bats I've never seen that are native to Ontario. This was my first time ever seeing eastern small-footed bats, and what actually got me, I did a forearm measurement on these bats because I looked, obviously they're quite tiny, and I thought, oh, these must be little brown bats, and then the forearm measurement didn't quite measure up, so to speak, and so then I asked somebody that I knew, like, hey, anyways, we ended up landing on this being eastern small-foot bats. And then I opened a box about, I think, 3 weeks ago now, and went, oh my goodness. So in the middle of winter, we ended up with an eastern small-footed bat, and the eastern small-footed bat was actually from downtown Kitchener, which is quite unusual for the species. I learned, and I made the same mistake. I assumed it was a little brown bat. I did a forearm measurement and went, oh my goodness, it's just outside the range of it being a small or little brown bat. I should make sure that I verify this. So Christy, I think she stepped out. Christy was very helpful and helped me identify this as an eastern small-footed bat. Unfortunately, the one that I got in 3 weeks ago didn't make it. And so it's at the Canadian Wildlife Health Cooperative right now for necropsy. So very appreciative of Christy's help because, again, at that point, you need somebody to help you out because, you know, I actually think in wildlife rehabilitation a lot of animals end up either getting released or end up in cadaver freezers, and a lot of issues, problems, and unusual cases end up that way because they're not properly identified as being an issue or something that should be brought to the attention. As an example, slightly off topic, quite a few years ago now, I had 2 snapping turtles in that were both horribly sick, and I had just sat through some presentations in the United States on rhinovirus, as well as herpes in turtles, which hadn't really been found in Ontario. And I had to jump up and down, slam my fist on the table, scream at people going, hey, you need to pay attention to this. This is a big deal. And everybody tried to placate me and told me, you know, be quiet. I got some cooperation from the Canadian Wildlife Health Cooperative. I had to actually euthanize one of the turtles to actually get it tested. And it took 12 months to the day to get a result back because the testing was so difficult, and it turned out to be the first rhinovirus positive snapping turtle ever. And so sometimes it's very, I know how much frustration I had going through that. I'm like, I know this is a big deal. Somebody listen to me. again, I'm picking on the MNR here. I actually did notify the MNR that we had a Rana positive snapping turtle, and the person that I was to report to, we have a condition on our authorization that says we have to report diseases that we find that can possibly be a threat to the species. The person that I was to report to told me it was really not a big deal and I shouldn't worry about it because she'd never heard of ranavirus before, so therefore it couldn't be a big deal. So at that point, Christina was still working at the MNR, and I called Christina and I said, hey, you really should disseminate some information to your field staff, which she ended up doing. But yeah, so that was a very frustrating situation. And so whenever people do give me some time, like Christy did a few weeks ago, I'm very appreciative of people actually taking the time and responding. Because I do think, you know, I didn't know that it was a big deal to find an eastern small-footed bat in a very residential area. It was found just outside somebody's back door on the ground. And I guess she was telling me there's been no records of them actually roosting in human structures, as human habituated structures, I should say. So it was kind of an interesting one. Unfortunately, the bat passed away. So this was an interesting one too. This is quite a few years ago now too. I actually assumed this was my first case of white nose syndrome. And I sent some pictures to the Canadian Wildlife Health Cooperative. I euthanized the bat on arrival because I didn't think there was any coming back from this. And sent some pictures to the Canadian Wildlife Health Cooperative, and I was told this is not really what white nose syndrome looks like. So I sent them to cadaver, and the final report literally read fluke fungal infection. So I guess it was a fluke infection that just went completely awry. I have never seen it since. I don't know if anybody else has seen anything like this. It was found outside of a jewelry store on the ground. So this we see a lot. Let me see. To your left, that's a bat that was stuck in a glue trap that somebody tried to remove and read online that you use vegetable oil to do that. The bat on the right was a bat that was excluded from somebody's property, and they used caulking to close up the holes, and the bat was desperate to get back in and crawled through the caulking. We see this a lot. I say a lot, maybe 6-7 times a year we end up with bats from glue traps, or the whole caulking incident is actually also not uncommon. I have yet to find a good resolution to the caulking issue. I tend to euthanize them, particularly when they're that covered. I can't figure out a compound that I can remove that with that is safe. The glue trap, we do remove them. I usually sedate them when I do that. And it's just, you just sit and it just takes a lot of time. They don't end up looking like that, by the way. We don't bath them in oil. So some of the challenges that we face in rehabilitation, again, no credentials required, so it's a learning curve. And then a lot of the information that's floating around out there is questionable at best. So there isn't a really great manual that you open up and you just, okay, this is how you do this. So all the information that is out there needs to really be evaluated with how valid it is. I do have a degree in animal nutrition, and I'm not actually originally from here, so my degree is from across the pond. But it's valid to some degree. So we don't actually feed mealworms a whole lot. We do use them as an enrichment tool, but we actually have a paste that consists out of several components, and I actually find the bats do a lot better on that than they do on just mealworms, even gut-loaded mealworms. Housing has been an issue. I've been experimenting with different things. We are actually literally just putting spades in the ground to build a brand new wildlife hospital, and I was very happy to see the captive colony here at McMaster giving me some ideas on building rooms for our bats. The periods of activity and inactivity, like I mentioned, even though some of the bats are hibernating, I know they're hibernating, I still see them move around and I see them climb down to drink water and eat. So that always raises some questions for me. And then when to release our scientific method is when we see bugs and bats. We live in a wetland. We live in a wetland, so when we see bugs and bats, then we figure it's pretty safe. So we pick a low wind night. Technically, on our one of the conditions on our authorization is that we need permission from the property owner to release, which generally results in us releasing them standing on the road. It's a bat, it flies, it'll go where it goes. Most people aren't really happy when you show up at their door with a bat, so it's just, as long as it's within a kilometer, generally, like literally, we just stand outside somebody's door because it's after dark, so nobody really notices. It's much easier to release bats than it is to release coyotes in downtown Toronto, believe me. Which we also do, also in the middle of the night. And then, you know, which species are here and when. In the 16 years that I've been a wildlife rehabilitator, we went from almost no data available to a lot more research being done. And what people were thinking about bats and presence has really changed over those years. And, you know, as in, there's been occurrences of silver hair bats overwintering here, which was never believed that they did. Lots of new data available, which is really kind of cool. And then I added, this is my last slide. Some considerations, being that we have a room full of really smart people. We banned all our bats, but there is no way to register those bans. If we look at our bird bans that are issued to us by the banding office, that the model exists. Can we please do something like this for bats? Can we please do it on an international level, because we do ban our migratory bats as well? We, as wildlife rehabilitators, need better lab access for disease monitoring. As it stands right now, we only have the Canadian Wildlife Health Cooperative, which will only work with dead. And it really blows when the animal is alive, and the labs tell you they can't either be bothered or they're not able to test your samples. We need better cooperation within our community, which is why I'm standing here today. And please share data. If I don't know who's doing research on what or what research has been done, you know, I'm missing out on opportunities, which is really kind of problematic. And so, you know, if you're doing research that is relevant, please, you know, don't forget about the wildlife rehabilitators. We are the boots on the ground. We work with bats on a daily basis, and we do need to know. And with that, I will take questions if I have time, otherwise I won't. Yes, go ahead. Depends on what's going on with the bat. So, how much does it cost to rehab a bat? It really depends. If they're injured, it's more cost. Cost more money. If they're overwintering a bat, depending if we get the bats in November till release, I'm going to say it's probably about $50 a bat, give or take. And that's mostly just, we don't count labor because wildlife rehabilitators aren't paid. They're also not funded. So we never count our own time. So that's just sort of cost of material. Yes? The Ministry of Natural Resources and Forestry has a list of wildlife rehabilitators on their website. Behind each wildlife rehabilitators, it says what species they can legally handle. So we need to have an authorization for each species group. So bats would fall under rabies vector species. So any wildlife rehabilitator that can handle RVS can legally take in bats. Go ahead.
I was just wondering, where is your location?
Nanticoke.
Okay, thank you, yeah.
Sorry about it's Hobart State Wildlife Refuge. If I can add one tiny thing, we bought 49 acres of provincially significant wetland and forest last year, and we are going to actually do some acoustic monitoring on our property. If anybody wants to help out, No, we just, Can we get migratory bats to self-feed? We can usually get them to self-feed, yeah. If they're injured and they're in pain, then they get hand-fed because there's really not that interest, but they also need to be medicated at that point. When they're not too bad, then they'll self-feed. They just come down and they eat. The wind turbine injured bats, because we do have wind turbines in the area, is a whole different ballgame. It's a whole presentation on its own.
Thanks, Chantal.
All right, everybody, we have about
Okay, guys, if you could grab your seats, please. Okay, great. Thanks, everyone. Welcome to the fourth and final session of today's meeting. Our next speaker is Karen Vanderwolf. Karen did her PhD at Trent University and is currently doing a postdoc at the University of Waterloo, where she's a Lieber Arrow Fellow. She's been doing bat work since 2006, and today she's going to speak to us about the Canadian Bat Box project.
So this works? Okay, I'm sure Toby is super excited that I managed to get here in person this time, so he doesn't have to give my talk for me again, as entertaining as that was. So I'm going to talk to you about the Bat Box project, which is a community citizen science project on a national scale. The first field season was in 2021, and this summer is the final field season for the project. We don't really have a catchy website, but if you just Google the name of the project, you're going to find lots of stuff. And I also produce a biannual newsletter as part of the project. This has updates and just general bat stuff for people that are interested. You don't have to be a participant to sign up for this. Just shoot me an email, and I'll add you to my giant email list. So this project is in partnership with CWF, Canadian Wildlife Federation, and Wildlife Conservation Society of Canada. And some of the CWF folks are here today, and it's the first time we've met in person after years of collaboration, so that's super exciting. And I just want to start with acknowledgements, because this is a massive effort with a lot of co-authors. So of course, the CWF people have been instrumental in this. I've tried to list all the professional biologists that are involved in this project. I'm pretty sure I'm missing some. And then of course, there's a lot of organizations that are contributing. They're contributing data, they're contributing in-kind support, and of course, cash. We always like that. So a big thank you to all of these people. And of course, last but not least, a huge thank you to the hundreds of landowners that are contributing to this project. Obviously, it would not be possible without all of these people. So what are the goals of the project overall? We're trying to figure out the types and placement of bat boxes that people are putting out on the landscape, and which ones are the bats actually using. So a part of this, of course, is documenting the microclimates in these bat boxes, because one of the concerns with bat boxes is the problem of them overheating. There wasn't a lot of data about that for Canada, and most of the current recommendations on bat box use that is available is based on research in the US and to some extent to Europe as well. So we wanted a huge goal of this is to produce Canada-based or recommendations that are based on Canadian data, especially if there's going to be regional variations in that. And I just put these pictures up because I really like them. This is in New Brunswick in 2019, so post-white nose, but it is an active little brown bat maternity colony, so it was really fun to see that, and we actually caught a nursing mother and pup there, so that was always fun. So methods. To sign up for the project, what happens is landowners must already have bat boxes or plan to do so in the near future. We don't mail out bat boxes. That'd be insane at this scale. So one survey is a really long one, and they have to answer all these really detailed questions about the size of their bat box, the placement, all that good stuff. Second survey is for emergence counts. So when they're counting bats in their box, let's see if I can get that straight. They can fill out the survey even if they see no bats, so I can actually track how many bats they're seeing in these places. There also, a lot of people don't know, of course, what species they have in their boxes. So there's no way we can physically visit all these places to see for ourselves. So we get these landowners to collect guano samples, and then we can ID the bat species molecularly. We're also looking at if the white nose fungus is present in bat boxes. So we're trying to get citizen scientists to swab the inside of their bat boxes for the fungus. One of the problems with this, of course, is that these guys, nobody has rabies vaccinations, of course, why would you? So we can't have them swab the boxes when bats are present. So from a science perspective, it's not ideal, but we have to ask them to wait until bats leave for the season. So this is usually late summer, fall. So not the best, but this is what we have to work with. So the reason I did this at all is because there's a study done in New York that found the white nose fungus in bat boxes. So I wanted to see if we could get similar results here. Finally, of course, to document the microclimate in bat boxes, we're mailing out a ton of loggers, and I'll come back to that later, for the people to install themselves in their bat boxes. So for the loggers, we've got a lot of loggers out there, and what we do, we settled on using log tags here. So we're trying to keep this as simple as possible because as landowners are installing them themselves. Again, at a national scale, there's no way we can go out and install them all ourselves, which of course, from a science perspective, would be ideal because then we can ensure it's done properly. But it's just, logistically, it's just not possible. So we try to keep this as simple as possible. So these look kind of like a credit card. It's a little thicker than that. And we also didn't want people to have to drill into their bat boxes, like permanently damage their box. So we came up with this method of, we mail them the logger on a wire, so it's all assembled for them. To mail it, of course, it's all curled up, so it's really easy to pop in the mail. So people uncurl the wire, and then they can extend the logger up to the top of the bat box and secure the wire with nuts and bolts at the bottom to hold it in place. So it's at the very top of the box. And we usually, depending on the size of the box, we'll send them more than one logger to try to document temperature variation within the boxes. So we had pretty good participation in this. Close to 1,400 people signed up. But of course, surprise, they don't all produce good data. So of that, about 800 has produced usable data. And when I say usable, it's still a very messy data set with a lot of missing information, which is, for a project like this, it's what you expect. It's what we have to work with. But it's still a huge sample size here. And you can see the distribution of the participants across Canada. Again, no surprise, it's not even. It's concentrated in the major cities where humans are found. So, humans up here, whatever. Southern Ontario, of course, very well represented compared to our one lonely site here in the Northwest Territories. At least we got one. So for occupancy, I have data on that for about 1,200 boxes. That's binary, yes, no. So about close to 40% are occupied, so that's pretty good. Of course, there's a lot of biases because people are signing up for this survey on their own, right? So it's not exactly all the bat boxes in Canada, of course. And unfortunately, of those 1,200, I only have information on how many bats are in these boxes in 255. So a lot of missing data there, but at least we have something to work with. So when I'm categorizing these boxes by how many bats they have, I'm not using day-to-day counts because that varies so much. What I do is I put these boxes into categories based on the maximum number of bats ever seen in that box or counted emerging from the box. So these are maximum numbers. And even with maximum numbers, you can see most of them have less than 10. So not huge colonies in these bat boxes. So one of the points of doing this, of course, is trying to identify maternity colonies, which is kind of tough. So for these less than 10, probably not. For the more than 11, now we're getting into maybe. So for instance, the photo I showed you earlier of the New Brunswick maternity colony, that actually falls into this category. So it is a maternity colony. But I also know of other colonies that fit into the same category that are not maternity colonies. So aside from the ones we can verify ourselves or by other professionals, most we can say here is that these might be maternity colonies, and these probably are. But anyway. Another thing I wanted to do with this is try to find out when bats are returning to bat boxes and when they're leaving. So take this with a grain of salt, though, because most of this isn't based on systematic surveys by landowners. It's just when they happen to notice them. Some of them are pretty thorough, really enthusiastic people. For instance, the Ontario one here, that person has really, really detailed data. She's super keen. She's near Niagara Falls with big brown bats in her bat boxes. So most of them you see, though, are coming back usually early May, and they're staying way longer than I thought, actually. So they're staying into the fall. But this is a bit misleading. So the bat boxes, in terms of occupancy, seem to sort of fall into 3 categories. So people have told me that they, across Canada, you have bat boxes that are used in the early spring, and then the bats leave for the summer, like in May sometime, and they never see them again. The second category is bat boxes that are used as maternity colonies. So you don't really see the bats until June, July, and sometimes they'll stay until the fall in those places, but everyone says like come late August, September, the numbers really drop off, and then you've just got stragglers. The third category is where they don't see bats, late August comes, the bats are there, which is kind of neat. So they see bats using these as transitory roosts in the spring and fall, and then the maternity colonies, of course, in the summer. So that's kind of neat. So in terms of what's important for occupancy in terms of bat design and placement, again, it's a very messy data set. I'm still going through the weeds on this, but some of the things that have popped out as being important is the year installed, so this is not surprising. The older the bat box, the more likely it's going to have bats. The number of boxes at the site, so some people have 1 box, some have 21. The 21 ones usually have more likely to have bats than the single box. What the box is attached to is important. So the trees have the worst occupancy rate. Poles are second. Best one, of course, wow, that really messed up, are the buildings. Wow, okay, we'll go with it. This is the building, in case that wasn't clear. Those were always the best in terms of occupancy, probably because of the thermal properties. The other variable that keeps popping out is, of course, in a lot of cases, people are installing bat boxes as part of their exclusion. So they're trying to get them out of the house. They're putting up bat boxes to try to compensate for the lack of habitat. So it's no surprise that those boxes usually have a better rate of occupancy because there's a bat colony right there. And they just go to the bat boxes sometimes, not always. So for the guano samples, we have about 80 samples pending, but we don't actually have any results yet. So I don't have a lot to say about this yet, unfortunately. We'll get there. Of course, there's a lot of roosts around the country that have been used by biologists for years, so we do have some where we know the species already. One of the downfalls of the guano sample thing is that the lab is only analyzing 1 pellet per box. So if it's a mixed species colony, we're not going to catch that. But I do have some confirmed mixed species colonies in bat boxes verified by professional biologists. So for example, Corey Olson in Alberta and Jared Clark in Saskatchewan. He's actually a bird biologist, but he did his master's with Mark Brigham, so that's good. For the swabbing results, we do have those back from last summer. So we have the sample sizes here. They're not super high yet. We're really trying to push this summer. So if anyone's interested in swabbing occupied bat boxes around, please get in touch, because I really want to increase the sample sizes of this. So here's the year where the swabbing was done, province, the months that the swabbing was done. And you can see that everything's negative until you get to the Maritimes, and that's where it gets interesting. And that's where, in Canada, where white nose has been the longest as well, except maybe for Ontario. We can talk about that. So PEI, we had an inconclusive in July. We had 2 positives in May in Nova Scotia. And then everything else was inconclusive, so in Nova Scotia and New Brunswick. So we are getting more inconclusives, positives in the spring. That is the best time to survey for this. But again, if we're having citizen scientists do this, it's just not possible. Wow, I need to speed up. Okay, I'm just gonna go. So detecting it by PCR molecularly doesn't tell you anything about the viability of the fungus. If it's just dead DNA, we don't really care. If it's actually viable and able to cause disease, then we care. So that's something I need to do, I'm going to try to do this spring, right here at McMaster, actually, with JP. I'll be swabbing bat boxes and trying to culture the fungus on agar. Loggers, we have a lot of loggers. Bailey's had a super fun month trying to program them all and ship them all across Canada. About half of these go through the CWF national office, so she's responsible for half of that, and the rest is by a bunch of other people. So our initial conclusions from that: the top of the box is hotter than the bottom. Surprise. For overheating, we definitely documented a lot of overheating events across Canada, including temperatures over 50 degrees. So the front chamber is hotter than the back chamber. Again, not really surprising if you're exposed to sun. Black, hotter. No vents, hotter. On the pole, way more likely to overheat than the buildings and trees. And multiple participants across the country reported bats bulging out of their bat boxes. That's a sign of heat stress, that they are overheating. But overall, occupied boxes are warmer than unoccupied. So warm is good, up to a point. This is my final one. One thing I just wanted to mention quickly is it did it again. A sort of side project that came out of this is people sometimes report odd roosts for bats to me as part of this project. So it's kind of come into this whole side project that Laurie Finney in Nova Scotia is writing up. So if you have any records about bats roosting on umbrellas or any really weird places during the summer, please contact me. I did contact the rehab people about this, and one of you got back to me and one of you didn't. So I'll be writing after you later. If you have any data to share with this, that'd be great. And something else with this project is we're trying to collate the bits and pieces of unpublished data related to bat boxes across the country, because a lot of people have, tucked away in their back drawers, data that they have about bat boxes that have never been published. So part of this is really trying to get everyone together to get a cohesive national picture of what's going on with bat boxes in Canada. And I'm done.
Anybody have any questions?
Yes. I was curious about your loggers, because I couldn't quite exactly figure out. Are they measuring the temperature of the exterior of the bat house?
No, so they're tucked in. That was for illustrative purposes. They're threaded. The loggers are threaded up into the bat box, so they're inside the bat box. Yeah, I can see how that was confusing there. Yeah.
So which part?
The wire or
The whole thing. It's threaded up, so you get the logger inside the box at the very top, or in the front, or at the bottom.
How is the wire? I'm confused. How is the wire related? So the credit card thing is just
The logger itself, and we attach a wire that we just get from the hardware store. It's a stiff wire.
What's the wire for?
To keep it up in the top of the bat box. Because how else would you mount it inside the bat box? What was the question? I've forgotten already.
How exactly are you deploying the loggers?
How I'm deploying the loggers, yes. Using the wire to thread it up, you thread it into the chamber, up into the top of the bat box, so the logger is sitting inside the box at the top, and it's supported by the wire, which is nailed into the bottom, the landing pad usually, of the bat box, so the wire stays in place.
So the sensor is located on the logger, not the wires that have nothing to do with the sensor?
No. The wire has nothing to do with the sensors on the logger. It's something we added for deployment. And if the picture hadn't mysteriously rotated, you would see that Parks Canada and some of the provincial parks have a slightly different system where they attach the loggers to a thin piece of wood. And it's kind of nice, actually, because you have this piece of wood. Let's say my arm here is the wood. They have the logger at the top and the logger at the bottom, both ratcheted into the same piece of wood. And then you can just install the whole thing in there. It's kind of nice, actually.
Time for one more question.
Come on.
How are you dealing with the occupied boxes being warmer than unoccupied boxes? Saying that warmer boxes are preferred, but if more bats are in a box, it's going to be warmer anyway.
Yes, no, that is a concern. So for when Yeah, so the presence of bats in the box is going to naturally increase the temperature for sure. And for professional biologists, one thing they do actually when they deploy these loggers is sometimes they'll put a sort of cage around it so that the bats aren't like snuggling up to the logger and messing with your data. But with this project like this, with non-professionals doing it on a national scale, like we had to keep this as simple as possible, and that just wasn't in the cards. And certainly participants have reported bats snuggling up to our loggers. So that it's a problem. It is what it is. There's not really much I can do about it.
Terrific. Thank you very much, Karen. Okay, we have our second presentation of the day from regarding rehabilitation. So we're very happy to introduce Jessica Benavides from the Toronto Wildlife Centre, and she will be speaking about bat rehabilitation and care at the Toronto Wildlife Centre. Jessica, take it away.
Thank you. Alrighty, well, thank you for having the Toronto Wildlife Centre at this year's Ontario Bat Network meeting. My name is Jess, and I wanted to share a bit about bat rehabilitation and care at TWC. Can everyone hear her okay? Yeah? So a little bit about who we are and what we do. We are a nonprofit wildlife hospital, and we're actually celebrating our 30th year anniversary. We are Canada's largest and busiest wildlife rehab center. We get in roughly 5,000 to 6,000 animals per year, and we are able to accommodate most of all Ontario species if they were to come through our doors. We provide an invaluable service to the injured, sick, and orphan wildlife here in the city, and especially being such a busy city such as Toronto, you would expect that we are sharing our city with our wildlife neighbors, but sadly that isn't always the case, and a lot of our intakes come in as a result of direct or indirect human influence. We're currently operating outside of Downsview Park, which is just north of the city core, but are slowly transitioning into our beautiful new property out at Rouge Park. The top photo is some of the compounds that we have currently built with enclosures, and we are already using it for outdoor caging. And in the bottom photo is a rendering of our new center when it becomes built in the next few years. And all of this will allow us to continue to help and take in even more animals. So moving on to bats, we receive a few of the Ontario species that are seen here, and like I mentioned before, a lot of them are coming in because of non-native influence. So some of our bats will be attacked by cats, for instance, and that's not just an issue with bats. We see that with migratory songbirds too. Some of our bats are also hitting windows in a downtown core. And sometimes there'll be instances where roosts are destroyed and they won't have a place to go. So I wanted to kind of show you roughly how many we take in every year over just the past few years and the breakdown of the species. We mainly get in big brown bats because they're more common, and they also will continue to come in during the winter time. And then the little browns, the silvers, and the reds, we get them frequently enough, some years more than others. We've gotten in hoary bats before, and a few years ago we got in a tri-colored bat. And then the other table is a breakdown of the reasons they came in, and I was just using last year for an example. Most of our bats come in because they are found in the wintertime and they are out of torpor. They're usually very thin and dehydrated, and intervention is required. Our bats who are coming in during the wintertime, after they are healed, they will stay with us until the springtime when it's appropriate to release them. And then we get in a bunch who have major problems, so that can be significant fractures or wounds. And these are probably the bats who, sadly, they may die shortly into care, or we have attempted a treatment plan and it may not be going very well. And then we have the ones who have minor problems. These are much better rehab candidates and they tend to do well with us. Some are NAF, which is just no abnormal findings, and they're usually back out the door fairly quickly. And then there's just always some other reasons. Like every year we seem to always get one that was found on a glue trap, for instance, or we'll sometimes even get some that are tested positive for rabies. And then when I had done the rough math, bats who are coming into our center and going to start a treatment plan, we had a roughly 70% success rate, which is kind of nice. So I wanted to break it down into how like an animal would come through our center. So it starts with like assessment, and then their husbandry, and then last would be release. When they come in through assessment, this is when we do a full exam to make sure that we can find anything that is wrong with them. So we are also checking their weights, their body conditions, their hydration. We'll sex them. We will check them head to toe for any of these wounds or fractures they may have. Sometimes when we get really young bats, we can age them based on like their teeth, if they have any milk teeth present. This was a really cool photo where we were able to shine a light and we could see joint space between the bones in the finger. And it's important for us to just have this information because if they're a young enough bat, maybe their diet needs to be modified so we can provide them with the appropriate nutrition. Yeah, so we also check all our bats for white nose syndrome if it's not very evident without the UV light. We wouldn't want to risk anyone we have in care already, so this is something we need to do. But since I've been working there and as long as I have known, I don't think we've ever had one come in with it. We also have the resources, fortunately, where we can take x-rays, which is a very helpful diagnostic tool. This bat has a femur fracture, which is probably a bit more evident, but if their rib or their collarbone is fractured, that'd be really hard and challenging for us to feel that on such a small animal. So having x-rays is a very helpful tool. X-rays can also help us confirm if a bat is pregnant. This was a red bat who had 3 pups. We also have a full-time veterinary department where we can anesthetize an animal and perform a procedure on them if need be, and we know we can do so safely. This was a silver hair who had broken its radius or its ulna, and we were able to splint it while it was asleep, which is much more ideal because if you try to do that on an animal who's awake, it's probably very painful, and you may not be able to put that splint on properly. And you know, with the healing of a fracture, one of the key things is you want good alignment. So the fact that we can have surgery and we can like do this with them, it just means a better outcome. So then once we have figured out anything that could be wrong with them, we put together their treatment plan and their care plan. If they need pain meds or antibiotics or fluids, we'll start them on a course. And then their care plan will just go over their diet, their weighing, and their cleaning schedule. Once all of this is done and now they are a patient in our hospital receiving care, the next thing we want to do is provide appropriate husbandry. Our bat setups end up being quite simple, and they do well with it. And mind you, we mainly get in the big browns, but it's just a pop-up mesh insect tent. We drape a little tea towel, and the bats like to nestle between it, and then they just will come down to their food or their water dish. We will then house multiple of them beside one another, and then we will further place like the shelving unit in a humidor, just so we can make sure we're meeting any humidity requirements. So right now, because it's winter time, our bats will come in, they probably have a wound or they're thin, so they'll just be in a warm humidor while they heal. And then once everything is good, and because we can't release them yet, we just put them into torpor, so a cold humidor, just so, you know, it's a bit less work on us because it's, you know, we're really busy as a rehab center, and then we can also be more hands-off with them. And then come spring, we're gonna actually be waking up our bats soon, probably next month. And then in the summertime, they're just always in a warm humidor. When we get some of the other species in, like the reds or the silvers, we try to modify their enclosures a little bit because we find that with these species, they're a little bit more particular. So if we can make it more natural for them, then that means they may be less stressed, and an animal that is less stressed is an animal who is eating better with us or healing better. Our diet just ends up being a variety of commercially bought inverts, so mealworms, waxworms, phoenix worms, and in the summertime we'll go out and catch the moths if it's feasible. And then our feeding methods end up being like a hand feed, and then we gradually try to get them to feed on their own just so we don't have to interact with them as much. So this is a brown bat who has figured out how to come down and eat his worms. It's usually a process. We just kind of slowly show them where the worms are coming from, and they pick up on it quite quickly. This would be an instance of us hand feeding a bat, so we just bring the worms to their face, And then we even get to a point where we do this while they're hanging in the tent, and then, like I mentioned, slowly they'll just figure out where the dish is. If they're not coming down to eat on their own yet, they're probably not coming down to drink on their own yet. So then we'll also hand feed them some water just to make sure they're staying hydrated. And then our last thing is release. We have some release criteria that we need to be met before we consider any of our animals. All of those original intake problems have to be resolved or addressed. The weight and body conditions need to be at a good spot for that individual and the species. And they have to be capable of flight. So living in such a small space for a long period of time, especially if they're in care longer, they're going to decondition a bit. So we just want to ensure that they can sustain some flight for release so that they are successful. And now that it's winter time, coming spring, for our torpor bats, we're going to make sure that the temperatures are at a place where we know that diet is available. And usually a good rule of thumb is when the other bats are out and about, it's probably a good time for ours to start going. So I wanted to show you a video of how we fly our bats. We have this hallway space that's quite nice to use, and we'll use a scoring system as we fly them. And if they score well, then they meet that flight criteria. And if they score poorly, we'll just work with them a bit longer. We'll exercise them just to get them to that point. And then they're approved for release. So we release them according to M&R policies, which is within 1 kilometer of where they were found. And it's always a continuous effort to set up all of our patients for success. So we're going to wait for a good weather window. If it's raining the next couple days, it doesn't really allow that individual to get their bearings. It's a disadvantage for any wild animal in captivity to spend time with us. You never know if their shelter or their food sources are compromised. So rather, if the next couple days are sunny and warm, that's going to be much better for that bat to get its bearings. And then I just had one last video of a bat release, which is probably one of the most rewarding parts working in wildlife rehab. Yeah, and thank you for listening to what I had to share. Does anyone have any questions?
Just be sure to repeat the question.
Oh, yes, of course. Hi.
I was just curious, you talked about the criteria for release, and I know with some larger mammals and stuff, they do blood tests, like that. Do you ever test them with flying prey to see how well they're able to, get that food on their own other than just the dish?
Yeah, so the question was live prey testing, I guess before release. Our new property out at Rouge, we actually have a bat aviary. And if there's reasons why we believe it may not be capable of eating, so sometimes we'll have bats who have lost an eye, for instance, or maybe they're young, we will put them in the bat aviary with food and we'll monitor what we put in there. Because unless it's a tiny, tiny little insect, some of the moths won't be able to get in and out. And we'll also video record it. And those are the instances where we get an idea if they're eating because their weights are stable. But for the most part, if our bats are coming in, they're probably adults, and we would like to assume that they were capable of eating before they came in, unless, like I mentioned, there's a reason to believe that now something has happened that would have compromised that. Exactly. Yeah. Any other questions? Hi.
Once the bats go through all the assessments to get to the point of being released, does it ever happen that they just won't go?
Physically? Or in care, we have deemed them non-releasable.
So you're at the point that the bat's about to fly away.
Okay. I've done a few bat releases. Okay. The question is that once we get to the release site and as we're about to release the bat, are there instances where it doesn't go? So we have a rescue and release team, and for the most part, that's on their end, but I've done a few bat releases, and usually once you are outside, and at least what I found is they're very eager, and I guess they understand that they're out in nature and something's about to happen. So for me, they've always just flown away, but I think there's been circumstances where they just sit there and sometimes they flutter to the ground, and at that point we'll assess do they need to come back in, and maybe we have to fly them again. But usually we give them a few opportunities. We'll have a slightly open space that we try to release them so that if they kind of don't make it far, we can recapture them. But I guess that's it's like a case-by-case scenario, so I think if it does happen, something is done along the way to like mitigate it. Does that answer your question, kind of? Okay. Anyone else? Hi. That's okay.
I know that it's difficult for rehab centers to have like funding and things, but I know that TWS is very large. Do you have veterinarians that are like full-time there, or do you just have veterinarians that you work with?
We do have some veterinaries who are full-time. We have some who are part-time, but they've been with us for many, many years. And to operate a wildlife center, you have to be in partnership with a vet. So she is like kind of like our full-time vet too. So yeah, I guess we have a few, and we have a few who are full-time and a few who are part-time. Yeah, it is. It's quite nice actually, because they're also very specialized vets too, right? They work with such unique animals. Yeah. Anyone else? We're good? Oh, sorry.
I actually have not so much a question, but a suggestion for both. For the UV lights, you have to do that in complete darkness and have a really strong UV light.
Yeah.
Otherwise, you can't see it. When I've seen it, it's like little specks of dust. And like if you have even your headlight or somebody behind you, you can't see it at all.
We do.
Yeah.
We do. We have a social media team, and we try to do things so it's like, you know, we couldn't do it in the dark. I wouldn't think so. So that video was just done with more lighting because the social media team wanted to see it too. But yeah, we do turn the lights off, and we do make sure it's like as dark as it can be, just so we can pick up on whatever little flecks there could be. Yeah.
Time for one more question.
Okay.
Going once, going twice. Okay.
Cool.
Excellent.
Thank you.
Thanks so much, Jessica. Okay, so our final presentation for the day before we do the big draw for the door prize is a presentation on the bats of Georgian Bay. We have two presenters, Stephen Kell. Stephen did his Bachelor of Science at the University of Guelph and his Master of Science at Laurentian, and for the last 4 years has been working out of Shawniga First Nation near Parry Sound. The other speaker is Derek Morningstar. Of course, Derek is the vice chair of the organizing committee of the Ontario Bat Network. He's the owner of MyodaStar, and he did his master's with Dr. Brock Fenton. Gentlemen.
Thanks. And bear with us as Derek and I tag team this presentation. So, Ooh, not that. Okay, yeah, so Shawniga, we've been doing a bunch of different species at risk work, really focused around reptiles, and then in recent years going on to some other things, one of those things being bats. And just personally, but also within our team, we've just really grown to really love bats and want to continue the work, and so we've been doing multiple different studies, working with multiple different partners. But really, we're at least for myself and the rest of the team, we're still fairly new to bats, and that's why we work with this guy over here who knows his stuff. And so we've been working with Derek for about 4 years now through most of our bat work. And as we've been working through the bat projects at Shawniga, we started looking at all of our local bat data and bat species in Shawniga, and we want to continue to expand that. We have a poster on some of the other work that we're doing. And then we started to want to look at a little bit more regionally what our bats are doing. And we were very interested in how they're maybe moving up the coastline using the outer islands. And so we were thinking maybe we focus a bit on that. And then Derek and I were like, oh, why don't, instead of just focusing on the eastern Georgian Bay coastline, why don't we focus on all of Georgian Bay entirely and try to go at an even bigger regional scale. And so this project came to be Apakawaj-Najin Midogami, which means essentially in Ojibwe, bats of Georgian Bay. And as we know, there's a lot of knowledge gaps with bats, a lot of knowledge gaps around Georgian Bay as well, for all the species and for a lot of those critical habitats. And there's really no better place to study those bats than within First Nations lands. A lot of First Nations lands are sort of a lot of the most diverse and least touched lands left around. So a really good place to start. And so for this project, we were actually able to have 9 First Nations all come on board, 6 in the first year of the project, which we're presenting on today, and then 3 more recently for the years 2 and 3. And so for the scope of this project, we really want to have a big community engagement in that. So for all the participating First Nations, having public nights, nights where individuals can come out, community members can come out, engage with those bats, see them up close and personal, sort of get over some of the fears that are associated with bats. We're trying to increase capacity within First Nations, within the lands staff, and within First Nations members. Every First Nation's different in their capacity, especially lands departments. Some have them, like Shawanaga, and some don't have any sort of lands department at all yet. So trying to increase that capacity for this type of research and monitoring, and then be able to continue on after this project's done. And the type of data that we're collecting is acoustics, netting, and then tracking both at local and regional scale through MODIS network, as well as handheld tracking, and then incorporation of TEK, traditional ecological knowledge. And I just wanted to put in just a quick statement about community consultation. Always trying to go for that golden standard of community consultation. We tried to do the best we could. With funding, it's always really hard. You never know when it's going to come in, what's going to be available. We tried to reach out about half a year prior to all these communities to sort of start building all those relationships before the project was even announced, before we even knew we had funding. We were reaching out, building those relationships. And then once we did know that the grant was funded, it's a lot easier to go in and start working with each of those communities, sort of on an individual basis, but then also as a collective.
Okay, so we're actually going to slide over because we're not in the screen. So we've done this presentation a couple times, and we have a little bit of information about bats in Ontario. All of you know this stuff. So of course, there's 8 species that we know of in Ontario. 4 species are listed. Another 3 probably next month are going to get listed by Kasiwik. But when you go into a First Nation or any area where there's no information, listed or not, they're interested in all species. So we didn't just drill down on the few SAR that we could find, and we were interested in all species, where they went, what they did, and learning more about them. So I'm not going to get too much more biology stuff. All of you know that. So we're going to talk about each of the communities that we visited and some of the success that we had. So we did netting nights at all these communities. The first one was at Wasoxing, where we did 4 nights, and we caught 83 bats in 4 nights. That is mostly because we had a nice roost in a house that we could catch a lot of them from. On the public night, we had 75 of them. That was kind of crazy. It was all little browns at that, and then we caught some big browns as well in a few places. That community has a lot of dark closed forests, so there's some really interesting spots where you can go and try to catch bats. But it is an island, so it's hard to get to some of those places. I'll just keep clicking.
Yeah, so for the tracking, we're going to go over pretty quickly for each community, not go into really any details too specifically, but at each community, we're going out there, we're working with the community members, working with the land staff, teaching them those tracking skills, those monitoring skills, and identifying those roosts so that they're able to protect that habitat and know where those bats are going. So we were able to, in Wasoxing, find multiple houses that they're going to, presumed multiple maternity roosts, as well as multiple trees. Here we have a large tree with a huge cavity in it, where multiple individuals were going back and forth between a house and this tree roost.
Okay, I'm going to go backwards because I meant to talk about the picture right there. We get lots of other bycatch as well. That's a flying squirrel that jumped out of the mist net onto James's arm and decided to hang around on his shoulder, and then tucked itself into his hood and stuck around for a nice photo op. So we catch lots of other cool stuff too. I just forgot to mention that. It's fun. Okay, so we're back here. So the next one we went out to was Magnetowan. So we did 4 nights there as well. We didn't do quite as well. We only caught 3 bats. All of them were little browns, but we were able to track them. That area is a lot of rock bear, and it's really open. It's not as dark. It's not as much closed forests, although some places we went to wetlands and forests. And we did it on the full moon, which was, in hindsight, not the time to do it. So bats are often ludophobic. They don't really like to come out as much in the full moon, and if they do, they can see your nets and they just laugh at you and keep on flying. So we'll be going back to Magnetowan to do something in a darker night, but that's the capture at that location.
Yeah, so all the tracking, no success in finding any bats in Magneto but the bats that we did catch there, we did find across the river in a couple different buildings. And so what Magneto One's going to do this summer is work with those landowners. One of them was actually a sort of resort that has just got new owners, and they're looking to possibly exclude the bats or do some sort of work with them. So Magneto One's going to be doing some public outreach and working with those folks with those bat roosts. So while we didn't find any in Magneto One, just outside, we found some, and they're going to be working with those landowners.
Okay, so next we went out to the Chippewas of Nawash, or Nea-Shinningaming community. We did 4 nights there, and we caught 79 bats. I'm going to run this video while I'm talking because it's a minute long. And we got 3 species there, including eastern small-footeds and little browns and some big browns. Public night was great. It was in a good public park. We had some good participation. This was a wild night of catching bats, and I'm going to explain it. So this is a church that's there where bats have been evicted, and there's a bat box right here, and we've put a harp trap in front of it. There's another bat box that didn't have any bats in it, but we looked at the forecast and it said might be a little bit of rain, so like, okay, we'll try, see what we can do. So we set it all up, and there's also triple high nets in both directions around this building, so there's a lot of nets around there and the trap. And there was, I think, 5 of us there at the time. And then the rain came in, and it wasn't just a little bit of rain, it was a complete downpour, like gushing down on us instantly with thunder and lightning, and I've got triple high poles in the air. So we quickly pulled all that down while getting covered in rain. Luckily I had a tent in which we could process, so this is processing bats in rapid fire. And we had, I think it was 67 bats in less than an hour, and most of them were in the harp trap. We had to pull that harp trap down. It was filling up with water and hopefully drained out, but they were all okay. And we processed those bats so fast and they all flew away fine. It was good, but the weather report was wrong. Don't trust the weather report.
Yeah, so we had a lot of success in tracking in Cape Croker. A lot of different structures that the bats were using, that bat house on the old church where they had been evicted, a couple different farm properties, some old buildings, which we had learned at the time were going to be torn down soon. And so now the community is going to be working to work with those bats in there, make sure that structure doesn't come down without working with the bats. And then also some different tree roosts as well. So the tree here you can see way high above the canopy, getting a lot of sun exposure. But a lot of bats that we're tracking back to sites that are I don't know, a couple hundred meters easily from the netting locations, and getting them out, flying over the bay at nighttime too while tracking.
Okay, so we went out to Whitefish River First Nation. That's a little bit north of Manitoulin Island. We did 5 nights there, and we didn't catch a huge number of bats. We only got 7 bats, but we had 4 species, so we had pretty good diversity out there, including eastern small-footed. Silver-haired's kind of fun, totally different to be able to catch out there, getting migratory bats. So that was really cool, and when we're out catching bats, we also like to get release videos, so I'm going to play that while we're talking. But at these public nights, that's the greatest thing you can do. So when you've got a bat in the hand, everybody gets to look and take a picture when it's in your hand and you've got a glove on. That's fine. But if you do a slow-mo release where you hold it up and get a good light on it, everybody can get their phone out. They get a slow-mo release video like this and they can take it and show to everybody. It's a great public education thing to do when you're releasing bats.
Again, yeah, a lot of good success with the tracking here. A lot of different tree roosts, as well as with that eastern smallfoot. We had multiple different rock sites that it was going to, including just a big giant boulder that was right in front of the band office that it went back to multiple days in a row. So some really cool data with the eastern smallfoot.
All right, so we went to Moose Deer Point First Nations next, which is on the east side, it's kind of southeast. In 3 nights, we got 27 bats. We had a building roost to work at there again. And it was, again, mostly little browns and a few big browns, so we did pretty well. Unfortunately, at that time, we couldn't do a public night because there was a COVID outbreak within the community and we weren't allowed to do that. So we're going to go back and have a chance to do a public night with them because we want all the communities to have that opportunity for people to see and know what's going on. So.
Yeah, I think this was mostly housing roosts that we found, a couple different tree roosts, but again, a combination of both buildings and tree roosts that the bats are using.
And we're going to actually talk more about where we track them. This one's kind of interesting, but we'll get to it. Okay, so the last of the ones that we're going to talk about now is we went to Shawanagas within their traditional territory, the tunnels, which is what the poster was about, and this is when we went out to do some netting of them. This was in September, so of course it's later in the season. We're looking for swarming activity. These are right on tunnels that are more like kind of man-made caves underneath the railway. In the 2 nights, we caught 2 bats, an eastern small-footed and a little brown. We later found what we think was that eastern small-footed hibernating inside that tunnel. So, this was pretty great to be able to catch them there, even though we got kind of unfavorable weather. We got a bit of fog, and it was also a bright moon night, so it was too bright, and then it was too dark with the fog. So it was kind of challenging, but we still caught some bats.
Yeah, and we caught a blue spotted salamander too, somehow, somehow in the trap. At Shawanaga, we had already focused a lot on our own roosts within the community, so we were trying to focus on these tunnels. Had not great success in picking up where this bat went. We got one signal, but not the actual location. So curious to talk to the others tracking eastern smallfoots about in the rocks. We were getting vague signals, but we weren't sure. Maybe it was underground in one of the tunnels or like up into a crack. We couldn't pick up a definite location of it. The other one we just couldn't pick up off the transmitter at all. But then this leads us into the MODIS network, so we weren't able to pick it up by hand, but did get it picked up on MODIS. And then we're going to talk about just the cool results that we had with MODIS.
Okay, we're going to skip this one because this is roosts we found within Shawanaga First Nation, but there's lots more roosts there, same thing. So these are just some fun pictures of what the capture and tracking. It's a lot of work, but it's a lot of great fun. Harp traps work awesome, and they work really good for different species like eastern small-footeds, so that's just pictures for fun. So then I'm going to talk about the MODIS network. So if you don't know about it, this is an international network of towers for picking up moving animals. So you put transmitters on them. It's the same transmitters that we track with locally. And this is the tower network in Ontario. And as you can see, there's a big gap on Manitoulin Island. There's no towers. Last year, we got these 3 towers installed, so there was nothing north of Manitoulin Island before that. So basically, if a bat flies within a kilometer or 2 of these towers, it would get picked up. So you get long-distance movements of bats, but you can't triangulate specific locations. So that's kind of how MODIS works, and the tower looks something like this. There's a few different versions. So we're working to kind of build on that too. We're going to be installing 2 or maybe even 3 towers on Manitoulin and maybe one at Christian Island this year. If we're lucky, we'll put one on the ferry that goes back and forth all day. That would be kind of cool. So when we're tracking on MODIS, it's long-distance stuff. I'm going to get cut off here, but we're almost done. So we can see some really neat so this is a bat that was caught at Whitefish River, and later we picked it up down here, all the way across Georgian Bay. And that was a little brown myotis. Silver-haired bats, they usually go a long ways. This particular one, again, from Whitefish River, decided to come down to, this is Moose Deer Point area. So this is crossing over between the different First Nations we're working with. And then from Shawanaga, one of the tunnels coming down in this area. So we had some really interesting stuff with the MODIS, and these are just a few examples. We've got 40 bats that had tags on them, so we have other examples where we can see long-distance movements and start to understand what they're doing. And I'll go back to...
Sure. So we had a knowledge-sharing event with all those First Nations participating. Went really well. Next year, we're hoping to have it in person. I think we're running out of time. We're super happy to welcome Michelle onto the project for years 2 and 3. She's up at the back there. Welcoming her to the bat world. She's going to be helping to incorporate a lot of that traditional ecological knowledge onto the project, so really excited to have that. And then next steps, so we have 3 new communities coming on this year, so we're going to be doing a lot of work there, and then revisiting a bunch of communities and some significant sites, visiting some caves. And then Michelle's starting. You want to do importance?
Yeah, so just kind of what we're working on here is not just the biology. We're not just trying to find out what's going on with the bats, although you get lots of that information too. But it's allowing these communities to help and get the information themselves when they don't necessarily have the expertise or having done it before. So everything we do within every community is with them. We're not just going in and doing it ourselves. Of course, Stephen from Shawanaga, but then we're going to all these other communities, and we don't do anything without them with us, and as many of them as we can, right? So they get part of the funding goes to them to support their staff helping us, and we try to engage with as many people as we can. So it's really important to have that experience together, and that's something that's really gone really well. And then, of course, there's all kinds of information about the roosts that we've learned here. So, and that's where we end it. I know we're too long, but it's the last one of the day, so. All right, thank you. Do we have time for questions? Chris says we have time for 2 questions. Any questions? Why are bats lunar phobic? You should probably ask the bats. No, it's, well, obviously the most leading theory is that it's to do with predator avoidance. So, you know, bats probably don't have a whole lot of predators in the night, maybe owls or something like that, but they still tend to avoid it. There's lots of other wildlife that's actually lunar phobic too on the ground, so I think that's a pretty common trend. But it's not, they're still out when the full moon's out and you pick them up on acoustics, but they also can see very well with regular old eyesight and they just avoid stuff. So they're out less and you catch them less. Unfortunately, that's just kind of how it goes. Pardon me? Oh no, it's supported by all kinds of acoustics, and most bat biologists that go out and net bats avoid full moon nights on purpose. Like it's a thing. Yeah. And was there another question? James?
Curious, with the endangered bats, how was it received by the First Nation communities? Because then there's Species of Risk Act implications with endangered bat locations, and a lot of these are homes. So it's a different scenario than other lands of Ontario.
So I should have repeated the last question. It was why are bats lunophobic? And now James's question is the sensitivities around identifying locations of SAR on First Nations. Do you want that or do you want me to do that one? Okay, that's a loaded question. So yes, these are endangered species. This is almost or usually on federal land, so the Endangered Species Act doesn't apply, but the Federal Species at Risk Act applies. So the rules are a little bit different. It's residences as opposed to habitat, different definitions, but it is still SAR habitat. But a big part of this is all these different nations are working towards self-governance. So they want to be able to manage the species on their own land, and they're being empowered to be able to do that, but to do that, they need to know a little bit more about these species. So this is allowing them to get that information and to understand how can they protect those species now that they know where the buildings are, what are they gonna do about it? So it's more about them making their own decisions. I hope that answered it right. You think that was good? Yeah. Do we have one more question, or are we? Christy.
Yeah, I was going to ask if you can share with one thing that you may have learned from any of these communities that you worked with about bats or not about bats.
Your turn.
Repeat the question.
Repeat the question.
Something that we learned from the communities about bats. That's. I heard of a story about the creation of bats. I can't remember the specifics. I would like to call on Arden, my field technician back there. But yeah, I'm gonna get this wrong. Do you want to answer, Arden?
You're not on the spot at all.
Now I'm shaking. I don't know if I'm, the proper person to be sharing this story. This is something you'd want to get from an elder in the community themselves, but one of the interesting things I learned was the bat creation story, which was actually a squirrel who decided to save the sun, who was caught in a tree. And as the squirrel went to save the sun, he was burned black by the sun. He was also blinded by the sun. So the idea behind the story is that after the squirrel saved the sun granted the squirrel wings and incredible hearing to make up for the loss of his sacrifice. So that's kind of a bit of the indigenous storytelling for you. Wasn't expecting to do that, guys.
Thank you so much. We appreciate that and recognize that the elders are the best place to get the story. Encourage people to actually seek out that story.
Thank you, Arden.
I think that's it, right? Who's
That would be me, I guess. Yeah. Michelle, you're up too. You're on the schedule, yeah?
turn the lights up?
Yeah. So, the live stream's still going. We're going to do the draw quickly, and then we'll do the closing. We are nearing the end, and we appreciate everyone's patience here. Landcare Niagara has generously donated the 2 bat boxes, and Brock Fenton has brought those 2 books from Lauren. So we're going to do the draw now. Hopefully everybody still has their tickets. This is you. So what are we going to, do you want to do the bat box first? So the first bat box.
Is it just the number I have to read?
Yeah, just read off. the number.
Okay.
That's all you need.
All right, it's 236-5051.
All right, so Carl's got the first bat box. You can come down at the end here. Once we've done the closing, you can come down and grab that. Next. Sure.
Ask and you shall receive. 236-5057.
All right, same deal. If you want to come down at the end, we'll get you the bat box. And if either of you need help getting it out to the vehicle, just let one of us know.
I hope they have a vehicle. If you took the bus, it's going to be challenging. Okay, this is for one of the books. Okay, Lauren's book, 236-5053.
Okay, somebody lost an opportunity. Yeah, restate it.
The number again is 236-5053.
Okay, yep. Sounds good. Renata, bring it down at the end and we'll get that to you. Last one.
Okay, number 236-5063.
All right. So yeah, at the end, after the live stream has stopped, you can come down and bring us the ticket and we'll get you the prizes. Thank you, Michelle. All right, so just bear with me for another few minutes here. That was awesome. I appreciate everybody coming out today. This has been amazing, and it's an awesome thing to see everybody get together and be able to come out and share this information. We have two things to give to some very important people that have helped us get everything together today. So Lucas, I've got a quick thing for you if you want to come up.
Yes, thank you, Lucas.
Just to give you some context, he didn't just start and stop the thing. He actually had to click through every presentation and every slide at the same time in sync with this because we couldn't get it to stream directly. So he's been paying more attention than probably anybody in the room. And he's done an excellent job. So it's a lot of work.
Like I said, it's just a gesture, and don't open it here, but yeah.
This was great. Thank you all for having me. I learned a lot about bats. I studied music, but so it was outside my wheelhouse, but it was a lot of fun, so thank you.
Yeah, and Derek really put it into context how much work he has done for us yesterday and today getting this all sorted. It's been amazing, and we really appreciate it. So thank you. And then Paul, sorry, yep. Paul, as the host, Paul McMaster, Paul's Lab, you took us for tours. You've done some great things today, and we really appreciate this.
My crew did the tour, so thank you to my students.
For those online, he's thanking his students and his crew as well. But I did. So similarly, we've got a card here for you, and I don't know if we're allowed to give this stuff out on campus,
yeah.
but
Oops. Oh, corkscrew, perfect. A bat screw.
Yeah.
And don't open this in. My wings are full. Thank you very much. Well, it's been an honor to be able to work with Brad and Derek and Michelle and Nicole and people that I worked with online and that I hadn't met yet, so thanks very much for coming. I really got to meet some new people today, including Chantel, and I'm looking forward to collaborating with her in the future. And if you have any questions about McMaster Bats or the Bat Colony, feel free to contact me. And hopefully we'll see you in the future.
Super. There is a little bit of space for that last tour if you haven't been able to get on it, and the last tour starts at 2 minutes ago. So as soon as we're done, we'll meet up in the lobby for that last tour. Thank you all so very much again for coming out today, and we'll look forward to keeping in touch with all of you. Cheers.
Reminder, by the way, there is a post-conference survey. You're all going to get an email, and you must fill it out. Absolutely must. But you can win a $50 US dollar gift card if you do. Just a reminder, watch for that survey. Fill it out. One of 2 cards, yeah.